Hello, welcome to this lecture. This is a part of masterclass on cloud computing for architects, designers, developers, and sys operations. Our main focus is Google Cloud Platform, but at the same time, we look at all other clouds to provide comparison between Google Cloud Platform or all other cloud services. As a part of this particular lecture, we will talk about what is cloud computing. Just a core understanding about the cloud infrastructure or cloud, mapping that to the real world examples. As per Wikipedia definition, what is cloud? Cloud computing is an information technology paradigm that enables ubiquitous access to shared pool of configurable system resources and higher level services that can rapidly be provisioned. So the provisioning is important with minimal management efforts upon over the internet. And this is the basis of the cloud computing. And there are some key areas here in this particular definition. It is in resource sharing. It is on demand available. It is a pay as you go model, available all the time, and most of the time it is over the internet. For you to use any cloud resources, you need to have a tool set using which you can provision those resources rapidly. And that is the power of the public cloud. And we will talk about different tool set in the example going ahead. Before getting into the computing world of cloud, let's understand what is cloud in the real world example. And here are some of the examples which I tried to explain it, what is cloud and how it maps to. So as an example here, consider a person wants to travel from point A to point B, or he wants to have means of travel to go from one to B, and this A and B is could be 100 miles apart or 1000 miles apart or 10 miles apart. That's altogether use cases which we can derive it to. But the person wants to travel from point A to point B. That is our use case. There are options. One is the person can have his own car. A person can use public transport like buses or trains, or they can use the planes if at all that is available. Let's take the first example wherein customer purchase a car to travel from point A to point B. What it needs to have? So he has to pay upfront all the cost for that particular car, whether he's paying upfront in terms of cash or owning it as a finance person, or that person has to maintain the car, like oil changes, tires and everything as a maintenance for that particular car, and adjust the performance depends on the need. And more importantly, either he can drive on your own or he can have private chauffeur. So these are different things which needs to be taken care by that particular person. Other option, if you don't want to pay upfront or your need is very minimum, right? And it is just for one particular day or something like that, or one particular month or week. And you don't want to pay upfront, or you don't want to have your own maintenance, or you don't want to take any liabilities of having a car, right? So what option they have? They can either go to Enterprise or Hertz or any other rental company to get the car and drive itself. Or they can actually drive using the private driver. There are some countries wherein you can't just self-drive the rental car, the driver comes along with the car. But that's what it is. So hiring a car from the rental company, that is one option. In that you are committed to the duration of that particular the rental period, right? If at all you are hiring a car for 1 week or for that particular day, you are paying full amount for that particular 1 day or for that particular week or month. There are other options though, and those options you can go Uber or Lyft share, right? Using which the car will come to you at the point A and will drop you to the point B. That is one option. You have it. You can use buses, you can use trains or planes. All of these options is not asking you to have this particular car or that means exclusively for you for that particular period. Like as an example, if you rent a car, you are locked to pay for the committed number of days. As an example, if you hire a car for 1 day, you are committed to pay for that particular day. If you hire a car for 1 month, you are committed to pay for that particular month. In case of Uber or Lyft, the bus, train or plane, you are sharing the resources, means the cars are moving around, and as because you need, you are just asking for that particular resource, car with a driver, and they will come pick you up from A and drop it to point B. You are not at all driving that car, you are not paying upfront fees, you are not paying any maintenance, you are not thinking about it like adjustable performance as an example. And if you are traveling from A to B and you have around 4 bags of luggage and with your family, you can ask for more big car like a van, right? You can, and you don't have to worry about whether that is available, because if you purchase a car or you have a car, if you purchase a car in that particular example, then and the car is 5-seater, you can't actually have multiple people like 6-7 people on that particular car, so you are locked to that particular available resources. That is not there in, say, Uber or Lyft or bus, train or aeroplane services. There are some usability versus suitability versus when you have a car, and when you don't have a car, you're asking for the resources when it is available, right? You can think of Uber, Lyft, bus, train and airplane. All of these are the cloud services which are available to you for the use or for that particular point in time, and you pay for that particular point in time when you use it. Like bus, train and airplane, you are not even exclusively having that service for you from point A to point B. You are sharing the bus with any other your travelers, right? So that is what the sharing means. Let's take about or consider about any other example, like if you want to construct a house. If you want to construct a house, you need to design it first. You need to understand how to construct that. So hire multiple people and construct it. Then you paint it, and then you take care of the maintenance. And for that, you need to maintain the software to design the house. You are maintaining all the tool set which is required to construct and paint the house, right? So think in all that context, if at all you want to do it and do it exclusively by yourself, you are owning all those skill set as well as the tools for you to do that maintenance or construct a house, right? If at all you are asking any other company to come and build a house, they will have their own tools to construct a house. They have people, they have tie-up with the company who does actual construction of the houses and ultimately paint and everything. So you are not owning anything. In that case, the service provider of the construction service, right, they have all the tool set. In case of maintenance, as an example, right, after 5 years you want to decide to paint your house. If at all you are owning that in the whole, you need to first understand how to paint it, and then you need to buy all those tool set which are required, and that requirement is for one particular use, right? You can even though keep it for forever, but there is no guarantee that all those tools will be still useful after 4 or 5 years again. So that is the whole concept of the cloud. In computing world, this is a new concept, because over last 20-30 years, there were no public cloud exists as such for enterprises to use it. And nowadays, they have option to go and use those cloud services without setting up their own data centers or having contractual services from the data center providers, right? So that is the concept of cloud. Cloud means ultimately sharing the resources, having it available all the time, provisioning those resources, and more importantly, elasticity. We'll talk about the benefits of the cloud, but that is what the cloud is, as I understand you can think of. So why cloud? Cloud solves 3 pain areas of the enterprises. Think about the pain area of setting up the data center, because enterprises are expanding fast. they will need some tools. They will need the data center to store their data, process their data, and make that data available for their consumers. And in that case, they have to set up either the data center, or they need to have a tie-up with the data center provider to provide that, to have that service. If you look at those services, having their own data centers is rigid and lengthy process, like you're owning a car, right? So that process is lengthy, and for that you need to have predefined set of requirements, hardware requirements. And if you look at the businesses nowadays, they are not strictly rigid in its nature like 30 or 40 years back. They are continuously changing their dynamics, and most of the time the resource requirements are not stable. Inefficiency, that is the second problem, which having a own data center is a problem. Like maintenance and enhancement of those IT processes, keeping those resources up to date, and ultimately you are doing all these things on your own. Ultimately you need to have your own resources for hardware maintenance, operating system experts, networking guys, cabling guys, all of that resource you have to maintain it on your own. And ultimately you have to keep up with the technology announcement. If the servers are getting phased out after so many days, right, because it's end of life after 5 years usually, you need to purchase new hardware and recycle the existing one with the company. So there are these you can think of as like rigid, fatty kind of processes which you need to get into, and everything is upfront. You are having the data center premises upfront, you are having the server purchases upfront, right? Cabling, rack and stack and everything, that is upfront, and you are managing on your own. So typical pain areas, or you can think of as like basic statements. My IT process don't cater for both on-premises and cloud-based services or the infrastructure. Technology is moving fast and we are not able to keep it up, and these are the statement from the CIO organization, not able to keep up with technology enhancement. And think of this is like technology enhancement is not only towards your hardware, it is towards the software as well, because when you purchase a hardware you need to run software on it, and there are license costs associated with it. If the company purchase software A for say CRM use, right, and after 2 years they realize that the software which they have purchased is not optimally usable for their use cases, and they need to purchase different one. The earlier licenses fee is lost, and they have to procure another license for another software vendor. They have to look at installing those software, upgrading those software, right? So all of that comes with those pain areas of having rigid or bulky in its nature to maintain it. And then all of this boils down to, I'm not sure I really want to own the resources or manage it in all my data centers. And typically you can think of the core businesses as an example. If the company is doing trading in share market, right, or stocks, those companies don't want to take all these burdens and then limit themselves for available capability, right? Available capability means number of machines, number of resources they have it, or they don't want to wait for, if they have some ideas which they want to launch it, they don't want to wait for 4 or 5 months to software procurement and ultimately having that available, or hardware procurement and ultimately that is available for them to use it. So what are the solutions? What are the options which they can use it? So there are the benefits which cloud provider gives it to them. Is first one is the flexibility, right? User can scale their services to fit their needs, customize applications, and access their cloud services from anywhere in the internet. And that's where you can say it is ubiquitous access for those services available from anywhere. And that flexibility gives us full amount of flexibility, right? If at all they want to launch some services into the market as an offering, they should be able to, the enterprise definitely, they should be able to do it without having constraint of IT infrastructure, and that's the flexibility which they will get it. In terms of efficiency, so enterprise user can get applications to the market, and that's where we said the clouds are taking out your core infrastructure procurement process thought out from you, and ultimately providing benefit that you just click it and then the resources are available for you to go to the market, right? And the value. So cloud services give enterprise a competitive advantage by providing most innovative technology available, and think of it as a software, whatever the latest version of software available that is available for you to use it, or the hardware, right? You don't have to worry about whether the software is updated or hardware is updated or not. So these are the top benefits of, you can think of, cloud. So we started with what is cloud, and then we understand what is cloud and some of the benefits of the cloud. We will get into more details of those benefits and cloud infrastructure in subsequent lectures, but in nutshell, that is what it is as a cloud. Thank you. Hello, welcome to this lecture. This lecture is a part of Google Cloud Platform certification training series for cloud architects, cloud designers, cloud developers, and system operations. Are you excited? We will talk about platform overview, and I think you should be enough excited to understand Google Cloud Platform in nutshell, right? So let's go ahead and get started. This lecture is a part of 2 lectures of platform overview. In this particular lecture, we will talk about Google Data Center, POP locations, network backbone, regions and zones, services offered, and GCP interactions. Why we talk about this? Because Google Cloud Platform, as you understand, it's a public cloud offering in the world, and using which you can provision all infrastructure resources using their tools. So before that, you have to understand how Google have their data centers, what are those locations, what are the high level concepts to divide the region, or you can think the geography into region or zones, right? What is the network backbone? So let's go ahead and understand some of those in these 2 lectures. Let's talk about Google Data Center. Google data centers are somewhat different from any other data centers in the world right now, and these are some of the highlights which you can think it is different from others. First one is renewable energy. So what Google has done is they have signed a long-term contract with the renewable energy companies to use their electricity from renewable energy resources for their data centers, and you can think of this is one of the good objectives where Google says after some years they are going to completely move their data centers operation onto renewable energy. The second one is the efficiency of data center. You can think of when they have considerable amount of experience in building the data centers for their existing YouTube, Google search, all those apps like Gmail or Google Drive, right? So they have experience, a considerable amount of experience in the data center operations. What they have done is with their machine learning experiences, they have learned that if you raise the internal temperature up to 70 Fahrenheit, there is no problem. The performance of the hardware goes higher, not the lower. The life of hardware is really good. And when you hit to like 70 Fahrenheit and more, ultimately you do not need heavy cooling air coolers inside it. You can live with outside air temperature for cooling the inside hardware, and that's how they use it. They build the custom servers, so they don't just procure the servers from the market and use it. They are not hardware manufacturer though, but ultimately they purchase CPUs, RAMs, and all whatnot, right, which is required to build a server. And they know what type of servers they will need to build it for their own data centers. And based on the research which they have done, they build their own custom servers. And in fact, they build their own rack. The way they organize the data, they build their own network infrastructure, right? So that's how that's how they know how to take advantage of efficiency of those servers and the network. Data and security, and this is one of the most or prominent aspect which enterprises look for. Typically, when the data is stored, where it is getting stored, and what about the encryption, whether someone gets access to that particular data, whether they can read it or decrypt it, right? So data in rest and data in transit, both kind of encryption is very much important for any enterprises, and that is what Google provides. And as well, like physical data center security, like there are some locations or data centers people don't even know where they exist, right, in physical world. So they sometimes take that thought as a not to disclose the data center location to anyone, right? So if you look at, there are a number of data centers across the world, and this is the map as on today, January or February 2019. These locations, you can think of all the blue locations. Those are the location currently exist, and they are planning to enhance. These services are getting continuously enhanced. They are adding, continuously adding their data center locations across the globe. Zurich or Osaka or in Jakarta also, they are planning to have additional data centers in 2019. They divided the whole region, the whole geography into multiple regions, and that's how they have divided this in 18 regions. These actually, the services are accessible through 225 countries and around 100 plus point of presence. We'll talk about that later, but this is the overall map of data centers they have it. Let's talk about point of presence. Point of presence, the location in which you can have the connection available, or you can connect to the Google's fiber optic network. If you look at here, the blue ones is their own network, and you can think of this is exclusively used for their existing services like YouTube, Google search, and whatnot. So all these blue network, this is their own network. But at the same time, what they have done is they have made investment, and these are like shared investment cables, marine cables. They have invested the money into that as well. So these are like partial ownership, plus blue ones are like full ownership by themselves. And looking at this particular, the network, you can think the amount of scale they have for fiber optic network, like having services in one particular location, like in US, if at all there are services installed, and if that is something accessed from Asia or Europe, they have fiber optic connectivity, and the traffic travel to their own fiber optic network and to the nearest point of location. So this is the network. These locations, you can see they connects the dots or the fiber optic connections. These are the POP locations for any customer to connect to the Google Cloud Platform. There are some of the POP locations which support CDN, right? And this is again a part of network where the caching happens for the customer data. If you understand the concept of CDN, the concept is usually, if at all you have some images, right, or the static content, which based on the request, it is accessed from the backend services or your servers. Rather than if that data is not changed frequently, what you do is you ask for the caching for those information to near to your customer, and that is the CDN concept. These are the POP locations, or the locations in which they have CDN support. So if at all you are accessing the services from US or the servers from US, even though that is not even the case, we'll talk about that, how you provision services near to you. But consider that example, right? Your server from US in India or in Asia, your not all the time the service will go to backend to access one particular photo or your profile photo, right? It will come from your nearest location to you. That's how our CDN work, and they have support for around 80 plus locations across the globe, and they have partners. So it's not only these services only providing CDN. but they have partners like Equinox or some other companies. They provide CDN locations, and that is some spanning across 500 or 600 plus. Regions and zones. Uh, as I said, they have divided the complete geography in multiple regions. So the region is independent geographic area that consists of zones, right? The main purpose of region is to host your application near to your user, reduce latency and availability. Let's talk about it, right? The region is the area divided into, it's an independent unit, you can say, of the complete geography of the world. And in that particular region, if you are hosting the services, it should be redundant enough that if one particular location goes out, you can switch back to the other location, but your traffic stays in that particular region or physical area, geographical area. So zones are like independent physical locations. You can think or map this to the data centers, and in one particular region you have either 2 or more zones, and that's where the services are hosted. So if at all the connectivity to say zone A goes out, the zone B is available for your customer to service, right? And that's where the concept of zone is there. So it is zones are independent physical locations within a region. Region is just a boundary defined so that your services are load balanced and high availability is maintained within the region. Here is the list of the regions plus zones in as per current, like January 2019. You can think Asia East 1, Asia East 2 these are the regions, and in which you have zones A, B, C, and likewise in US Central you have multiple physical locations A, B, C, and F. So when we look at a Google Cloud Platform, we are more drilling down into the actual services or the resources, right? These resources, anything, right? Like your virtual machine or database instance or your IP addresses, all of these are network and somehow computing components, I would say. These components are either it is in global in nature, means accessible across all the regions and available across all the regions. There are some regional resources only stick to that particular region, and there are some zonal resources like physical, actual virtual machine sits inside the physical location, and that is, even though it is accessible from all, but it has presence in one particular physical location. And the example I said, virtual machine or VM disk, those are the zonal resource. If you go out, if you look at the static IP address, that IP address is specific to a region. So it is not a global resource. It is specific to a region. And then you have the network, right? The complete virtual network. If you want to create a virtual network, virtual private network into GCP, that span across multiple regions. So that is a global resource. Disk images, global resources, because image is a service, and you can access any disk image from anywhere. The snapshot, whatever you store it, that is a global resource, and your definitely firewalls and all those defines a particular physical locations and the rules around it. But these are so the resources are either tied as identified as a global resource, as a regional resource, or zonal resource. GCP services in a high level, right? So they have the services from infrastructure as a service to software as a service. So let's talk about what are those in nutshell, right? If it is infrastructure as a service, this is traditional data center model, right? Where you have servers, machines, CPUs, network interfaces, and everything, and you manage the software and platform around it. So the virtual machine typically is a computer on the cloud, and you can think that as a infrastructure as a service. You connect, you have your hardware like disk. If you provision a disk to store your backups, right, that becomes an infrastructure resource. Or you want to have 32 CPU plus 128 GBs of RAM in a particular virtual machine, that also become infrastructure as a service. That's where you manage, you provision those resources and control those resources in terms of usage of that resource, the disk and everything, right? If you go from the left side to the right, your operational overhead gets reduced. So if you look at the platform as a service, that's where you will have the ready-made platform which you can provision it, and you can just deploy your applications onto the platform, right? And in that case, you don't have to manage the actual hardware, but you are managing the instance, you are managing the cluster. It is not the actual hardware, but it is on top of that particular actual hardware. Google takes care of managing the actual hardware for the cluster, but you manage the performance of the cluster, and then you provision the cluster resources, right? If you go to software as a service, that's where you move towards more and more serverless environment. You don't even care about the cluster, provisioning those cluster or the resources for your applications to run. What you do is you typically just push your code or application to the platform, and platform start just running it. You are not worried about how much the cluster size is, or how many virtual machines you are using, the CPUs and all that, right? You are just careless about it. You just use the resources and do all other application level access permissions and all that. So that is purely so from left to right is purely a moving towards no operations kind of work, where left you are managing so many resources, and that's where IT operations come in. Then you have system operations, which is in between platform and infrastructure as a service, because IT ops major towards is when you are owning your own data center, right? SysOps is you have the resources available, and you are just managing, connecting those resources, managing operations around it, and this onwards up to no operations is what the public cloud environment is. DevOps, you are utilizing existing cluster and management, and provisioning the resources based on its requirement. And ultimately, no ops means they have App Engine, right, as a resource. You just push a code, and the application will start running, and you are least bothered. You don't even know what are the resources which are running inside it. You are just build based on the traffic or the consumption of different hardware resources for those services. So in nutshell, we are looking at a different kind of resources, and typically if you look at IT organization, what they use the compute resources, and in typically we see a virtual machine or your server, right, a physical server. That is your compute resource, which is doing manipulation, calculation, accessing a database, and serving your customers. The second one as a resource is the storage, and compute and storage is typically only two resources which typically IT needs it. If you look at, or business needs it, sorry, IT is not the right word. IT needs, on top of it, IT needs, there are so many services, and we'll talk about it. So data is what the business needed as and when they want to have it, processing of that particular data and serving that data to the customer, right? And that serving is handled by the compute services. But to have either the data or the compute resource available for a user to access it, you need to have a connection, and you need to have control on that particular connection. And that's where Google's networking service comes in a play, and you have multiple options to use it. Beyond or on top of these three core services, you need to have identity and access management, so that resources are accessible to the person who needs to have access to, and all other people should not be able to access it. There are big data services, and this is another benefit from the Google Cloud Platform. They are very innovative in developing the data solutions and the big data work. They are really good at machine learning. And we understand more about it, how you can use the machine learning. But these are the core services you can think of, which enterprises use it as their own data center, install the software, have the hardware. Besides that, there are other management tools which are available for anyone to use it. It's like Stackdriver offering like monitoring of IT resources and application resources, logging, error reporting, trace, like that. as well as the developer tools. So having all that information infrastructure available, how you will use the APIs inside your the applications, and that's where developer tools comes in a play to help any enterprise to build the service or use service Google services inside the applications. Besides that, they have come up with another service offering. Google Cloud Endpoint was the only offering which they had it earlier as a API management tool. We'll talk about what is API management, and we'll get into how it benefits customer doing the API management. Last year, they have acquired a company called Apigee, and they were very prominent in doing the API management. So using Apigee, you can do API management, monetization, analytics, and whatnot. But it's not a marketing page, but we'll look at it. What is that? If at all you are moving to a public cloud environment for the first time, or you are having connection between your own data center because you have some services which you want to keep it in your data center and you want to connect to Google for elasticity, then there are these data transfer services which they have created. And I think Google Storage service and BigQuery data transfer service, I have not seen this 2 years back, but this is available right now for customer to use it. That's it, guys, for this particular lecture. We will get into more details of resource hierarchies, projects, quota, infrastructure services, and different type of accounts, as well as pricing in next lecture. Thank you. Google Platform Overview, Part 2. In this particular lecture, we will look at resource and its hierarchies, projects, quota and limits, infrastructure services, GCP accounts. There are different type of accounts. What are those? And pricing. So in nutshell, what is resource? A resource is any component. As an example, virtual machine is a resource. Disk attached to that particular virtual machine is a resource. Or the network component in which the virtual machine is hosted is a resource. Your firewalls are a resource. Your database is your resource, right? All of those are resources in GCP. And those resources are organized in hierarchy manner. And we'll look at that. What is the hierarchy, resource hierarchy. Typically, if you look at any organization, the company has got multiple departments, and individual department will have some products like product 1 and product 2 here, but it could be anything, right? Whether it is a unit of that team, or whether it is unit of that department, or directly department requires the IT resources. So it could be anything. You can mix and match any hierarchy, you can create it. This is a part of, so organization and folders are a part of G Suite. We'll talk about that in subsequent lectures, but G Suite maintains organization and folders, and project and onwards, you can control that in Google Cloud Platform. So you already have organization built here in G Suite, and you do it. It is not mandatory though. If you want to build it organization, you can do it there, but you can have your individual accounts for a different project, different departments, and they are maintaining their own resources. But there are some restrictions, and we'll talk about that, how you can share the network and like that. Okay, but typically your resources are allocated to a project, and ultimately using project you can provision the resources. That's the container for your cloud resources. Hierarchies. So you want to implement the way you want to give access to a different team or applications to different applications, and that is built out of identity and access management. But as well as you want to have the resources, the billing, right, which goes from top to up, right, where you want to bill it, whether you want to bill it at the project, or you want to have the billing account created, taking say 4 or 5 different departments together, that you can define it. And the roll up happens from bottom to up for the billing. So typically identity and access management will happen from top to bottom. So if if a particular person has got access to a project, all resources inside the project that person will have access to. But there are fine-grained access control which will need to enable for that particular person. But the way it works is IAM is top to bottom and billing is bottom to up, wherever you define it. There are policies in IAM, and we'll talk about that later, but the policies are the set of resources applies to rules or members. Resources inherit policy from its parent, as an example. So all these resources inherit properties from the parent, which is like project. Policies are union of parent and the resource. Like if at all we are talking about one particular person having access to App Engine, then those like union of what project has it plus what permissions or in terms of role has given to a particular person. If the parent less restrictive overrides more restrictive resource policy. As an example here, if the person has got a create resources policy, I'm just giving an example, create resources at the project level, but you can restrict whether he can create an App Engine or not, right? And that's how the hierarchy or hierarchy of IAM works. For the billing though, usually organization is the full container of all your resources inside it. Project is typically usually you will have the billing happen at the project level and not at the product level, but you can have one billing account created and taking the pay, talking about aggregating the payments for multiple projects. IAM role hierarchy, as we said, it's a top to bottom. There is nothing much, but just elaborative how and what you can do. As an example here, organization admin have full access over all the resources. Organization viewer view access to all the projects. Folder admin create and manage different folders. Folder viewer can only view the folders. Project creator can create a project, and resource roles like individual resource role here. So we saw there are some resources which are zonal, regional or global. Typically, if we carry that over here, typically the instances and disk are zonal, external IP at the regional level, and images, snapshot and network, it is at the global level. Typically, your billing happens for all those at the project level, billing and reporting at the project level. Typically, GCP resource manager. GCP manage means resource manager manage all the resource which is depicted here. Like this is the resource manager's work to maintain this hierarchy. So it is centrally managed hierarchy, centrally manage and track all your projects, manage IAM across your organization, manage organization and organization policies, create and manage cloud IAM policies, cloud console and IAM access, and manage cloud folders. And this is a part of resource manager. Service account. So you have two types of accounts in Google Cloud Platform, and we'll talk about service account later in one section. But in a high level, a service account is the account which is used for application to application access. As an example, right? Virtual machine wants to access GCP resources, cloud storage resources like images from cloud storage, or write images to the cloud storage, right? We will have a service account created which will be used by application inside the virtual machine, and that account will have access to the cloud storage. And this is fine grained, and you can define what that particular service account can do or can't do. And definitely this isolates the user level permissions, which is like user, if a employee leaves the organization, right, or a employee move from one organization to another organization, another department within an organization, then you don't want to go ahead and switch all those permissions to the new employee. It's additional work, right? So instead of that, if you use service account taking care of all application to application level communication, you are careless, like whether we employee joining in or leaving the organization. used based on secure token, and there are three type of service accounts in nutshell. You can create your service account. You can use built-in service account for virtual machine and app engine, and used by Google API internally. So typically these accounts are used by APIs. No, the service account which is used by API, you don't have any visibility. It is just created in the platform to use it. And we'll talk about that in demo section. When you open or enable the API access, how you get the API access using the service account. GCP project, as we already understand, project is a container for all your resources. Project takes care of billing for all the resources within that particular project. So what project does in nutshell, it tracks resources and its quota usage. You can have billing on those resources. You can manage permissions and credentials, and you can enable and disable API and the services within the project. Project use 3 identity attributes. One is project name, project has got a number, and project has got a identity as well, ID. You can interface with using Cloud Console or a resource management API to the project. Cloud resources and quotas. So typically, if you look at you want to have some level of quota or limits for your cloud resource, because what we understand that the cloud resources are infinite in nature, right? You don't want to see surprises in your cloud bill on a monthly saying that this is not the case, but your the revenue is say $100 and you got $120 cloud bill, right? As because you can go and use as much as you want. At the same time, you need to make sure that your IT spends are controlled. It is not actually intentional, but someone is monitoring your quota, right? And that's where you have quota and limits for those resources. So quotas are typically controls the budget. It limits your resource utilization at different levels, and you can definitely increase the quota if the organization is big and you need multiple resources. You can increase that quota. There are some limits which are enforced in GCP, and those limits you cannot increase. So that's the difference between quota and limits. So typically the limits are, you can think of platform limitations, and quota is something constraint which is put forward as a recommendation from Google, but you can still request for the quota to be increased, and Google will look at the different use cases and will enable additional limit, increase the quota for you. Project quotas. So typically the resources are subject to project quotas. How many resources you can create per project, how quickly you can make API request in a project, like rate limit. Some quota limits are applicable for region and zone as well, and you can increase this quota. As I said, the example of this quota is you have 5 network per project and you have 3 CPUs per region, right? As an example, but these numbers may change when you see this particular a slide deck or training. GCP infrastructure management services. Typically, if you look at any cloud offering, right, or your own on-premises data center, or you procure any data center services from any other service provider, you will need to organize these resources. You will need to have the network, but you will again need to have some way of interfacing it to your resources, right? And that's where infrastructure management service comes in a play. You will have resource manager, which organize your cloud resources in projects, folders, and ultimately individual resources. You have IAM, which is using which you can have fine-grained access control across all the resources. You can have audit also set up, or logging also set up on IAM, so that you see who is accessing what services. These are the services which is provided under Stack Driver as an umbrella. for monitoring, logging, tracing, debugging, and error reporting. There are some CI/CD applications, or to make your deployment easy, you have deployment manager. You can just set up template, and you can create your own infrastructure. And then you have storage and scaling, right? Auto scaling or pub/sub. These are the additional services. Auto scaling actually makes the services elastic, in which usage of the virtual machine CPU goes certain 80% or 60%. You can configure a rule to spin up multiple of those virtual machines, and your service SLA is not hampered. So these are the infrastructure services which are available for Google Cloud Platform or any other service, any other cloud platform providers. Interactions. So how do you interact with the Google Cloud Platform? There are typically three ways you can interact with Google Cloud Platform. One is using UI. So you can just go to GCP console, log in there, and then just start provisioning the resources, or you can view the resources. Second option is command line interface, or CLI. You can install that in your computer, or you can go to Google Cloud Platform and you can spin off shell, cloud shell, and you can interface with the cloud. And the third option you have is the endpoints or REST libraries, right? You can interact using the REST endpoints, and each and every activity which you do it using CLI or the console, you can do that with the REST APIs. You can use simple call command or postman to call the REST API, and you are done. You can provision the resources, monitor the resources using the REST API as well. So that's all around different aspect of Google Cloud Platform. Please let me know if you have any questions. Otherwise, we'll get into the next lecture, which is different certifications available on Google Cloud Platform. Let's understand what are those, so that we will focus on what is that it is that we need to focus on this particular training. Okay, thank you. Hello, welcome to this lecture. In this particular lecture, we will get into more details of certifications offered by Google Cloud Platform. Typically, there are these three certifications, like Cloud Engineer, Cloud Developer, and Cloud Architect. Let's go to the website and understand what are those. So here I'm just typing Google Cloud Certification. The first link pops up is the details about the certifications. Out of these certifications, the one Cloud Architect and Cloud Data Engineer, these are their, you can think of existing or old certifications, which they originally had multiple, and they normalized it into these two. But on top of it, they have created these new certifications like Cloud Engineer and Cloud Developer. Cloud Developer is not yet launched, and Cloud Engineer is launched. So this was in beta mode earlier. And now I think it is waiting to get the production version of Cloud Developer. So in a nutshell, Cloud Architect and Cloud Data Engineers, they are existing certifications or old certifications, and Cloud Engineer and the Cloud Developer, they are new certifications. G Suite is their own collaboration certifications, which they had it since so long. Probably you're aware about it. But this is where you can actually go ahead and check their certification details. If you look at node details, this is where you'll understand what is that certification is, and go here and you can see the outline of this is the detailed syllabus for your certification, right? We'll get into details of that. But you can actually go here, check yourself with your the questions, click here for readiness, and this is where you can think of launch the exam, and you can actually give somewhere around 20 questions, and this is like free questions given by Google Cloud itself. But you can, if you are sure that you have good understanding, you can just check it here whether you are ready for the exam or not. Or you can practice from this particular training, you can practice the questions and then understand yourself. Going back to the slide deck. Okay, so cloud engineer and cloud developer is their new exam, and cloud architect is the old one. The data architect I'm not including here because that is very specific to the data related services like big data, AI, and all that, and that is not the focus of this particular certification understanding or the cloud as a core services understanding. All these certifications need understanding the purpose of each and every services and provision those and use or monitor. In addition to that, if you look at cloud engineer and cloud developer, these are the people or the stakeholders who will manage applications onto the cloud. Architect is more oversighting, understanding the core essence of each and every services, how to plan more towards how security is maintained or managed, how to set up those services, how do we comply to the regulatory requirement and all of that. Cloud developer is more towards how he can deploy his application, take the advantage of cloud's different APIs or services, right? Where to deploy. There are multiple options which they have it to deploy their applications onto the cloud. Which one to choose? What is the best way they can deploy their applications? And cloud engineer, if you look at what they're expecting, you will need to understand set up and configure cloud, manage cloud day to day, manage security on the cloud apps, monitor cloud resources and applications, understand the purpose of each and every services. And this is where the traditionally you can think of DBS database, database administrator plus system administrator, right? Those roles come in play, and now it is called system operations, cloud sysops, but they don't have somehow in Google space, they don't have system operations as an exam, but they have cloud engineer. And the expectation here is he should have enough understanding or good understanding about the cloud console, how do you provision different services, monitor them, scale them, right? So he's like hands-on doing each and every activities day in day out. Cloud developer, though, he is deploying the solution and taking advantage of cloud environment, accessing their APIs, that kind of a role, and he's more towards focusing on the application deployed. Versus cloud architect is more towards plan and design solution. Which one to choose? What out of all those services? How do we manage security and compliances? How do we analyze or optimize technical and business processes? Manage and implement like cloud architecture and ensure solution and its operational reliability. And what does this mean by is how do you make sure that if the load goes high, you are taking care of auto scaling aspect, or wherever you are actually subscriber base is how you are planning to provision the service near to your consumers, right? All of those. Typically our focus here in this particular training course is the cloud engineer, and he should have understanding about individual services, manage those, and set up security around it, including monitoring. A developer, we are not focusing here, or even cloud architect, we are not focusing in this particular journey. So how do we learn? If we look at a cloud engineer as a certification, the person who is doing day in day out activities onto the Google Cloud Platform, and that is the expectation, right? So for that, to understand the whole Google Cloud Platform, what we'll do is we'll start up with the setup. Setup means how do you set up the initial account, right, onto the Google Cloud. So I will take you through the project, IAM rules, APIs, how do you enable, disable APIs, how do you monitor your services using Stackdriver logging, and some understanding about those. So we need to have account to have this one. And then all of the cloud resources, you will have, the billing account using which the cloud bill will be paid, right? So how do you configure the billing accounts, budgets, alerts, bill export, right? How do you export the bill into analytics? And then we'll have detailed understanding about the SDK, CLIs, and console. The second aspect we'll get into is, and that is section 3, of the curriculum, plan and configure Google Cloud services. And this is where we will get into each and every services, understand it, understand their benefits, plus and minuses of each and every services to make the decision which one to use. And then we'll deploy the services. And when we are saying deploy the services, there are 3 different group of services which any or enterprises will use it. One is the compute service, second one is the data service, third one is the network, and that's where you security, you put forward securities, you create VPCs, firewall rules, load balancers, subnets, all of that in the network. And once you configure everything or deploy the applications, you need to make sure that the applications are up and running as and when the customer is required or business want it. And that's where you configure auto scaling, traffic management, disk, network monitoring, logging errors or alerts. You put forward audit measures, and you make sure that access permissions are in place properly. So this is our focus in this particular training. So how do we, understand all of that together? We will get into details of curriculum or the syllabus for the exam, but here is some of the thoughts, right? So first we'll do a setup and IAM management. This is where we'll configure basic setup. Compute service, we'll get into understanding about what are the compute services which are available for us to use it, like virtual machine on the cloud, right? A computer on the cloud, if at all what we need it, right? We'll get into planning, configuring, deploying, and managing the compute services like App Engine or even GKE. We'll understand data services, and then we'll understand networking services. What I have tried to done was I have tried to group it together so that the syllabus is spread across multiple sections, will be understood in that particular section. As a compute service, we will get into planning, configuring, deploying, and ultimately managing the computing services like data and the network. All of this will have different options to use it from the cloud. Basic concepts, we'll get into basic concept of each and every service. We'll launch it using console as well as CLI as a demo, and then we'll get into some samples so that you can try it out on your own. That's it for as an introduction. We will get into exam outline in the next chapter. Thank you. Hello, welcome to this section. This section is the next section in the series of Google Cloud Platform certifications, and this is Cloud Engineer. Are you excited enough now? In last section, we saw the Cloud Console, CLIs or SDK. We went through projects, how you can attach billing account, how you can enable, disable APIs, and we saw a little bit about the service accounts or different type of accounts. So I think by now you might have went through the Google Cloud Console, like create your own account, get $300 credit, and browse through different solutions. Let's go ahead and get into individual services understanding. In this section, majority of the cases, we will not get into the Cloud Console besides the pricing calculator. This is more towards theory, wherein we learn more and more concepts about different components or different services offered on Google Cloud Platform. The name of this section is Planning and Configuring Cloud Solution. And in this section, we will cover pricing calculator, planning and configuring compute resources, data storage options, and network resources. So what is that we learn in this course, in this section? This section is all about knowing what is it about a particular service, right? As an example here, computing services. What are those services? What is compute service in nutshell? Why do we need it? What are different options available? Why those different options even exist today, right? We will go over trade-offs. Why do we use one service over the other service? And then we'll get into console. I'll just walk you through different services and just until you click how to launch those services. We will not get into details of individual services yet. In terms of database service, we will understand what is the database or storage service, or why we even use it, or where do we use it in real software world, right? And then we'll look at why there are different options exist, like Cloud SQL, Hadoop, and etc. Why we use one service over the other one, and I'll take you through the console and looking at all those different services. And then we'll talk about the networking services. What are components of network? Why do we use it? Why do even network exist in today's world, right? What is the importance in the cloud environment where we are going to create a global data center in your private network? So how you can provision your resources so that others cannot access it, right? How you protect your resources if at all you are created database service, or you are storing some sensitive information, you need to make sure that no one has access to it other than your organization. And within your organization also, you need to protect those resources. Only give access to certain people and not to all for those resources. So this is knowing, in nutshell, knowing what is it about all those services. Let's go ahead and get into it. The first point here is the pricing calculator, and using pricing calculator, how you can get the discount, how you can understand what is your bill going to be for 1 year. We will get into details of pricing calculator in the next chapter. Thanks. Let's continue on compute service basics in planning and configuration cloud solution. We saw there are three main category of core services. One is computing platform, second one is networking, third one is database and storage service. Out of which, in this particular lecture, we are going to cover basics of computing platform. What do we mean by computing platform, or what are the core services of the computing services? In computing service, we have virtual machine, we have container engine, we have app engine, we have cloud function. If you look at why these particular services exist today, those are broadly categorized into plain simple machine or computer in data center or cloud. That is your virtual machine. You can install anything and everything what you wanted to have it in the cloud, and that is virtual machine in the cloud. Code and container platform, that's where you have microservices architecture or container applications, and you want to deploy your application onto the cloud platform, and you don't want to install or manage the infrastructure hardware by yourself. That will be managed by the platform itself, and that's where app engine and container engine comes in play. In serverless architecture, definitely that's where you want to pay only for when the code is running, and that is purely in the context of serverless architecture. We have multiple options there provided by different cloud vendors. In AWS, we have Lambda, a function in Azure, and cloud function in GCP, and these are like only the serverless environment. If you look at the way you manage computing services in terms of whether you are managing the hardware or complete infrastructure, or it's like zero operations platform, right? And this pyramid shows the bottom is like you're managing the operating system and all other infrastructure component, and when you go up, you are not really managing anything, you are just deploying your code. So starting with the virtual machine, that's where you choose operating system the way you want to have it, or you can have your own image, you can install that in virtual machine. In container, you just deploy your container, you manage number of nodes, you manage how the traffic splitting will be done. In apps platform, you do not manage the cluster. The cluster is managed by Google itself, and you just push your code and then it will be executed. The load balancing or traffic splitting or auto scaling, that is baked inside the platform, and you do not have any control on top of that. Whereas cloud function is purely you're just pushing a code and your code is not executing continuously, and that's where you will be charged only for the time when that particular code is executed. And that's where you can see you're executing one particular program block in the cloud, and you will be charged for that particular time. Before we dive into computing service basics, let's go ahead and understand what do we mean by computing service, right? In earlier era, like this is an example of 1999, I worked for a project and in which we were developing website plus you can think of application which will do airline reservation system for its customer. This company was based in Mumbai, and initially if you look at their original thought, they used to get a call from customer for any booking reservations for airline. What they have done is 1999, as because it was, as you can very well map it, it was .com era. They have developed a website which will take the customer's request about airline reservation, and then this request is stored in a database, and that request is checked by the associates. They will open the request, they will check what is required from which day to which date, plus point A to point B, and then they will call customer and they will verify what they need, and they have an interface, Galileo interface, and this is, you can think of as like centralized server somewhere as a centralized reservation system for airline at that time. So they will look at all possible combinations and options, and over the call they will satisfy customers' need. Those record is stored here in this particular server, but at that time physical copy has to be issued as a ticket. So they will issue courier a ticket to this customer, but the information is recorded here, and that's how accounting happens, right? So this was the start of automation, which they went ahead. The Galileo has the DOS interface over TCP connection, which associate were using it at the time. In subsequent year, in the next year, what we have done was in 2000, it was it was looked at as a data in data center is not safe, because at the time it was not security was not proper. And there was a chances that data would be stolen from the data center. There were small data center services across so many locations in the world, and we were using one of the data center in Mumbai at that time. So it was decided that let's have a database server locally in the headquarters itself, instead of it is sitting in the data center. So what we did was, from the data center to the headquarters, we they laid a lease line. So you can think of, when you configure the lease line, you need to make sure that the firewalls are configured here properly, the routes are configured so that it can understand the machine which is sitting inside the headquarters. This machine should not accept any other request other than the data center machine, as well as the machine which are sitting to service our back office people. So besides this particular implementation, additional thing which was done was they were able to program it so that they, instead of actually the associate putting forward the request, all the customers' request will automatically query to Galileo database to get the current availability, and that was shown to the customer in near real-time manner. So it could take somewhere around 10 to 15 seconds at that time. I think that's what my understanding is. As of now, I forgot actual numbers, but a customer used to see what options they have it. And this was like in 2000, and we said, wow, this is like amazing thing which customer has it, right? And at that time, Expedia and I think Travelocity also was prominent in the business in US, but we were able to make the query. Then after, we had another server like Sabre. They came up with the XML interface, and that was another, you can think of, next milestone achieved. And we were able to configure even payment interface to this. So this was, the way you can think of it was established was, you need to have something in the data center which will take your request as a web server. You have database running in your headquarter, you have lease line, and sometime if there is a cable problem here, your services are definitely down. It was not fault tolerant, to say, because the internet speed was not there. The website was taking huge time to load the image, because we designed a nice graphics on the home page of the customer when customer logs in, and some of the interactions. So we had to reduce those image loading, because all the images were stored here in this particular machine. Every time we had to change the configuration, we had to rush to the data center. If at all we had to upgrade hardware, we need to install it properly and then replace the hardware box from the data center. There was whole lot of problem, but ultimately it was like a really good achievement for us that everything is just working fine. So hardware procurement, having those connections established, as because we had a fear that data will be stealed from the data center. There was too much of network configuration. The firewall was inside this particular operating system and the routers. There was firewall connections between Sabre and, or you can think of VPN connection between Sabre and our web server to query to Sabre. So this was all, you can think of looking at the current ease of use, the painful thing to establish and to start the business in web, right? Looking back or coming back to the compute service, right? Compute service means this is a computer who is acting as a web server, right? And that's where you have Apache server installed. This is computer again. This is computer taking the request. This is again a computer, and we have installed Oracle afterwards in 2001. But again, this is as a physical, it is computer. We have a database installed on it, on the Linux machine. So all of these are like computing service for us as of today, right? And this was sitting inside the data center for us as our servers, and these are third-party servers. But this was our computer in the data center, right? The same way you have your computer in database, computer or the database servers in sitting inside the data center. That is what the compute service is. So you have flexibility to configure routers, firewall rules. You can install any software and you can make that available for you to work, right? And these are some examples, or the servers which you buy it from the market and install it in the data center if you want. This is like, big data appliance. This contains operating system as well as the big data software solutions from Oracle. But there are variety, hundreds and thousands of varieties of way you can procure those hardware and install that in database. Coming back to the cloud, right? So you can easily map, right? So compute engine is the box, the physical box, and they are running virtual machines onto that physical box. So you may have in one particular physical box like this one, multiple virtual machines running inside it, and that is your compute engine. And that virtual machine is because in traditional way you have only one operating system running in this particular box, but now you have the hardware is virtualized and you have multiple virtual machines based on the requirement, the way you configure it, running in this particular box, right? And that is the virtual machine. So whenever you think about the requirement, you want to deploy some custom code, you want to make use of operating system, the computing engine is the starting point to go, right? So when do you use it? Probably some of those use cases you will not understand unless we hit to the next services, but let's go ahead and get it started, right? There are some applications currently, those are containerized. I'll talk about that in some time, but the application you can't containerize, or you have OS level dependency or OS level changes, or you want to host your existing application without rewriting it for containers or app engine, or you want to have full control of your hardware in looking at the network, looking at the compute resources, right? And that's where you use compute service or compute engine. So some of the features of the compute engine is it is a virtual machine with network attached and ultra high performance local storage options. You can have preamtable virtual machines. We'll talk about that. But preamtable virtual machines are something which you go ahead and just build from the available pool of virtual machines. And if that machine is available, you can get up to 80% discount on that particular virtual machine. It is all depends on how much machines are available for any customer to use it, and based on that you get discount. But you do not have full control on those preamtable virtual machines, and we'll talk about that later in the next section. But the only thing to remember is you have preamtable option, which is not there in the other services, to use it as a computing service. And you can get up to 80% discount, but there is no guarantee that you will continue to use preamtable virtual machines as 100%, because they can take your virtual machine anytime. Customizable load balancing and auto scaling across homogeneous virtual machines. You can have direct access to GPUs that you can use it to accelerate any or specific type of workload. You have support for most of the flavors of Linux and Windows operating system. That's the compute engine. That's the compute engine. Kubernetes engine. So, it was not long back, actually last 4 or 5 years. The microservices plus containers, all those are like really dominating in terms of technology space, because it's ease of use, the way you can deploy, you can manage your code. There is a specific requirement of CI/CD, and that's where Kubernetes popped up as a container orchestration tool. And this Kubernetes service is developed by Google as a server, and that is now even implemented by Azure as well as AWS, and they are providing this service as well. So Kubernetes engine in the cloud in GCP is managed cluster. You can deploy your microservices or containers into Kubernetes without managing the hardware. So when do you use Kubernetes engine? You have secure and scalable way to manage containers in production. You don't have dependency on specific operating system, and this is on the other hand, if you have dependency, you have to use virtual machines. Application should be containerized, and that is the basic requirement for you to have it when you are planning to use the Kubernetes engine. We'll talk about it later in the detail section, what is Kubernetes engine, but it is a container orchestration tool for you to deploy your containers and manage your cluster inside the cloud environment. Some of the features of Kubernetes engine: it is seamless computing resources provisioning across the globe, and you can have a cluster actually running globally, serving your customers globally. Auto scaling and highly available cluster, container management and orchestration. It is a logical infrastructure, and it will provide you a platform so that you can deploy just your container and just don't worry about the underlying hardware. Easy mechanism for building loosely coupled distributed system, and this is one of the advantage of containers. Run as a same application on your laptop or on premises or a cloud, and this is not a benefit of Kubernetes engine. This is a benefit of containers, right? App engine. So this is again another, so it has got a multiple versions of app engine, but typically the motivation behind app engine is you as a developer just write a code and push it to the app engine. The remaining thing is taken care for you by App Engine. So it is just zero. You can think of zero operations platform. It has got two different versions or two different type of app engines, but the main motivation is it's a zero operations platform. You can build reliable and scalable serving apps or components without doing it by yourself. And this is doing it means without provisioning infrastructure first or platform first. You just push the code or deploy the code and code will start running. It minimizes operational overhead. It has got a developer velocity or infrastructure control. So you can't control the infrastructure in most of the time, or that is the motivation, right? And you focus on writing the code and never want to touch the server. And this is in the context of compute or cloud engineer. You are managing someone else's code, and that is what you need to understand. So App Engine is the platform service from Google Cloud Platform, wherein you manage the applications which is written by someone else. In demo, in the next section in demo, we'll have additional in demo. We will actually get into details of so what I'm trying to do is I will give you the application code itself. You do not need to understand what is inside the code. I will give you some other thoughts on how to modify the code and how to push that particular application. But as a cloud engineer, you do not need to worry about how to write that particular app. Okay. Some of the features of App Engine: a stack with smart defaults and deep customizability. And this means you have actually the defaults created for you, but you can actually get into customization and you can customize it the way you want to run your app. It supports almost all the languages like Java, Python, PHP, Go, Ruby, Node.js, and like that. Or you can even bring your own runtime environment in flexible mode. Integrated SDK, managed services, and local environment deployment, and this is where it actually shines, right? So you can run your app. You will get the SDK, you will get the local development environment, and you can execute it, and you can see it happening in your dev machine without even deploying that into App Engine. App versioning with zero downtime upgrades. So this is again another benefit. You can create multiple versions, and you can split the traffic between the versions, and when you get the confidence on the new version, you can move all the traffic into the new version. Automatic high availability and built-in auto scaling. So you don't have to worry about how to manage the high availability and scaling. Cloud Function, this is 100% serverless environment. That's what you can think of, and it is event driven. So when you want to use it, typically Cloud Function actually gets executed based on your event triggers. Event trigger means, as an example, you stored something on the server and you want to process. As an example, you push the video file onto the server and you want to convert that video file in multiple formats, right? That you can trigger with the Cloud Function. It is event driven. You don't have to manage any environment. You do not control the CPUs which it is using. Everything is managed for you. The main benefits: you do not want to run app with no one is using it. Absolutely no operation overhead. Simple to implement and with multiple endpoints, and event based code business logic execution. And this is you can think of like it is not a continuous execution environment like your virtual machine, your Kubernetes engine, or your app engine, right? This is event based. So when something happens, that's where you want to run the code, and you want to pay only for that particular point in time. You don't want to pay for even 10 minutes or 1 hour for that particular machine. And that's the powerful that's the power of cloud function. You just pay for 100 millisecond slot. As an example, if your code gets executed in 80 millisecond, you'll be charged for 100 millisecond. Your code is executed in 170 milliseconds, you'll charge for 200 milliseconds. So like that, right? It is when your code is running, only that particular time for your computing resources you will be charged, otherwise you will not be charged. So some of the features are, it's a true serverless environment with serverless economic, which means you will be charged only when the code is running and not charged when the code is not at all running. Connect and extend cloud services. It is mobile ready. You just go add a code and it will execute as and when it gets an event. It has got an open source support. You can primarily use it for IoT as well. You can even develop APIs and microservices. You can even do data processing and ETL job based on the events. So different computing services, typically we saw virtual machine when you want to use it, when you have OS dependency, or you want to have full control on hardware and network, or you want to have OS level changes, and that's where you use virtual machine. When do you use container engine? Container engine is when your application is fully containerized. If it is not containerized, you can't use container engine. You don't want any, you don't have any OS level dependency. It is scalable in the production load, which means you want full control on how you can scale it, based whether you want to put auto scaling implementation on. But the main thing here is your application should be containerized, then only you can use container engine. Whereas virtual machine, you can use it for any purpose. It is just machine or computer in the cloud. App engine, this is shine when you want actually developer deploying the code in the cloud environment without having any knowledge about the platform, or managing any resources as such, like hardware or operating system. It is scalable. You can have traffic splitting and all those features out of the box. Cloud function, this is purely event based and purely serverless. I just wanted to go ahead and get onto this dashboard or console, Google console. I just logged in. I just wanted to show you where is the compute service, right? If you go down here, this is compute service. You can go to either app engine, compute engine, Kubernetes engine, and cloud functions. Let me go ahead and show you some of the parts of virtual machine. So the first task here is, because I don't have any compute engine running right now, I can just go ahead and create one. You can choose region and zones where you want to host your machine. You can choose CPUs, memory, or you can customize it the way you want to have it. You can even ask for extended memory. We'll see this in later. If you have a graphic load and you want to have it, you can attach graphics. You can choose even operating system and all that, right? Go here. You can go to compute engine and you can create group template, and you can use this template to launch multiple instances. The disk, if you look at, you can create a disk. These are like magnetic disk or SSDs, the way you want to have it, and you can manage different snapshots. We'll actually go ahead and get into details of all these in the next section, but this is where you can go and launch compute engine. This is where you can just go ahead and launch app engine. Kubernetes, same. For Kubernetes, you need to have a cluster, and Kubernetes is container orchestration cluster. And you need to specify how many number of nodes you want to run, minimum number of nodes versus maximum number of nodes. If at all your if you are consuming more and more resources. So you can actually get this enable API, right? This was not enabled for me, so I'm just enabling it. So this is the compute engine. Okay, it's not challenging. We'll get into details of each and every compute service shortly, but this is how you can go and browse. Let's go ahead and understand the different data services that we have it for use. That's it for this particular section, guys. That's it for this particular chapter. Let's go ahead and understand what are different data services which are available for us to use it. Thank you. Planning and configuring cloud solution, data and storage services on Google Cloud Platform. In this particular chapter, we are going to look at high-level overview of data and storage services on Google Cloud Platform. Data and storage service is one of the three core services which is offered out of any cloud platform, whether it is providing MySQL or Oracle or SQL Server, Hadoop, DynamoDB or MongoDB, Spark, Cassandra. All of those services are database and storage services you can think of. So data and storage services are highly divided into three different categories. The first one is data and storage. That is plain simple SQL, NoSQL databases and object storage like images. Second one is big data services, which contains Hadoop, Spark, Apache Beam, and all those implementation out inside Google Cloud Platform. And third area is artificial intelligence, wherein you learn machine learning, speech, vision, natural language, API and translation. There is essentially not really management required in speech or natural language or translation APIs. We'll get some glance of machine learning in this particular section. So there are these different services which are offered out of Google Cloud Platform as a managed service from Google. Cloud SQL. This Cloud SQL is MySQL and PostgreSQL implementation, and this is managed service out of GCP. Cloud Spanner, they have designed their own relational database management system, and we'll talk about that later in this section as an overview. But this is the relational database management system and globally available. Then we have Bigtable. It is, you can think of Edge-based implementation in Google Cloud Platform. Cloud Data Store. This you can map it to the MongoDB kind of implementation. You can store document database inside a cloud storage data store. Cloud storage is object storage. You can store images, static content in the cloud storage, or you can even store in your backups or the data for archival purposes. Big data services. We have Cloud BigQuery, that is EDW onto the cloud, enterprise data warehouse on the cloud. We have data flow, and that is you can exchange the data between, or you can treat this as a ETL engine, right? This is Apache Beam implementation of ETL. That's where it supports streaming as well as batch integration. Dataproc, this is Spark and Hadoop clusters onto the cloud. Data Lab, this is a visualization tool which you can use it on BigQuery or any other data backends. Cloud PubSub is integration service, and this is, you can think of it's like typical messaging service. This is treated as a big data service because it is highly scalable, no management in terms of hardware or the backends. You just need to create a publisher subscriber and just start using it. This is a part of Hadoop, but you can treat this as an integration framework or a platform service which is required for you to do any integration work, right, as a part of messaging. So why do we need data and storage services? Because once you have virtual machine onto the cloud, you can just install cloud SQL like MySQL or PostgreSQL or any database software which you want to use it in Google Cloud Platform. Why do you need the data and storage services? The critical reasons are, you can think of one or two, right? And those reasons are like, you don't want to manage operating system and its backbone. You don't want to manage the storage attached to the operating system. Everything should be managed by the cloud, and that is why they are offering as a managed services on all those services. On top of it, you don't have to manage the software installation. On top of it, you don't have to manage the security around those databases. So everything is out of the box available for anyone to use it. What is that for a cloud engineer? If you look at a cloud engineer as a certification, you do not need to understand bits and pieces of each and every components of those services, in terms of how you can write SQL queries, in terms of how you can deploy, how you can push the file into Hadoop databases, or how you can run the Spark jobs, right? You will need to understand what are those components which are available for you to manage those components onto the platform. You're not writing any queries, you're not writing any files or data files, you are not manipulating any data files, but you are just managing those infrastructure components inside the cloud. So let's go ahead and get into it one by one. The first one is Cloud SQL. This is fully managed MySQL and PostgreSQL, and this is relational database management system. If you have any requirement on the MySQL as a database backend for your example, for your website or any requirement, right? You can just go ahead and go to the Google Cloud SQL and launch the service. Let me go to the console and show you a little bit about it. You can go here. You can go to Cloud SQL, and then you can create an instance, and you have two options. One is MySQL and PostgreSQL. You can just go ahead and launch those instances and start using it. So that's the Cloud SQL. So you don't have to manage operating system behind it. Everything is managed for you by Google. So why do we use it? For all RDBMS requirement based on MySQL and PostgreSQL, that's where you use Cloud SQL. As a ERP or CRM or e-commerce application backend or geospatial data application backends, websites, blogs, or CMS, or the BI application, web framework or structured data, OLTP workloads. And this is typically look at if at all you have something implemented in MySQL or PostgreSQL, you can just go ahead and leverage all your existing implementation onto the cloud with some constraint, and we'll talk about those constraints in detail section. Cloud Spanner is their next database, and same RDBMS database. They have built this particular database from ground up, and this is only available in Google Cloud Platform. The biggest advantage for Cloud Spanner is it is horizontally scalable, strongly consistent, globally available database, and all of those keyword has got a meaning, and we'll talk about that in its individual section. But that is, you can think of Cloud Spanner is relational database management system. It is ground up implementation, and it is highly available and global scale. So why do we use it? All our DBMS requirements. You have ad tech, financial, global chain, or retail data. You want to scale horizontally with consistency in the mind, and you want to have mission critical application spread across the global, and you want to have the database which can take query from all the regions, from all the locations in the global scope. How do you go to and launch Spanner? You can go here and in Spanner. So this will take some time to enable an API. It's enabled. If you go to create an instance, it will ask some typical questions, right? The name, typically, instance ID, and you want to have this particular instance as a regional or multi-regional, and this will drive your ultimate availability of your nodes. And then if at all it is regional, then you need to specify which region you want to have it. If it is multi-regional, you can just name where, in which side of the geography you want to have it. So cloud spanner is charged based on the nodes. As you increase the number of nodes, your cost will increase accordingly, right? So that's what it is charged. So the storage cost depends on the GBs per month. Node cost is hourly for this particular node guidance, and you'll have actually this guidance everywhere in Google Cloud Platform wherever you have a doubt, and that's how you can go ahead and create it. I'm not going to create the instance as of yet, but that's the Cloud Spanner. The next one is Bigtable. Bigtable is, you can think of it's a column DB and HBase implementation onto the cloud, Google Cloud Platform. Why do we use it? It has got a native time series support, and you can use it as a IoT, finance, or ad tech. As an OSQL database, you can have personalization, recommendation, monitoring, jobs configured to use Bigtable, geospatial data set as well as graphs, and low latency read write access. And this is very important aspect. You need to make sure when you have low latency read write access, high throughput analytics, your first choice is a Bigtable, because that's the column DB, and the way you pull the data is very fast as compared to that of SQL. Let's go ahead and browse where it is. Bigtable, and here it is. You can just go ahead and create instance. It will ask you name, which instance type do you want it, production, which means it will create at least 3 nodes for high availability, the storage, SSD versus HDD, and you can think there is this particular cost estimation given all the time whenever you are configuring those services, right? So for 4000 GB, 680 per month, right? Or you want to have low cost storage for 4000 HDD 104. You can actually mix and match all those numbers. You don't have to launch it. You can just browse what options you have it initially, right? Unless and until you launch it, you will not be charged. The next one is the cloud storage. Cloud storage is a scalable, durable, multi-regional object storage. What do you mean by object storage? Typically, the blob storage means usually when you install your operating system, that's the blob storage, right? Object storage means you are storing one particular file or one particular image or video file into the cloud, and the way you manage it, you can either store that particular image there, or you just retrieve the image, and that's what the object storage is. So it is highly scalable and durable, and we'll talk about what do we mean by scalability and durability, what do we mean by multi-regional, and it has got different storage classes. What are different storage classes? But keep in mind that cloud storage is object storage. That's where you store a file for your archival or images or whatever, and you will be charged based on the type of storage you are using it, plus the size of that particular storage in monthly basis. Importantly, cloud storage cannot be used as a operating system backend. Means if at all you have, say, virtual machine and you want to store operating system or you install operating system onto cloud storage, you can't do that. It is not in blob storage or binary storage. It is purely an object storage context. Why do you use it for? Storage for your custom data analytics or pipelines, archive, backup, and disaster recovery, storing and streaming multimedia data like images or videos, images, pictures, videos, or objects, blobs, or unstructured data for your storage. And you can go to here, and this is part of, again, storage. you can just go ahead and create a bucket. And this is a bucket is a, you can think of it's a folder in which you have you are storing your objects. So that's the bucket name. You need to specify the storage classes, whether it is multi-regional, regional, nearline, code line, and based on that the charging mechanism changes, the way you retrieve the data changes, right? And here are some examples, right? Storage cost, it's a 2.6 cents per GB per month. Retrieval cost free for some of the multi-regional. If you change this, you will have retrieval cost as well, right? So if you create a bucket, you're not going to charge for a bucket, but if you start storing the object, bucket is just a container or a folder, you can think of as a directory structure. But if you store additional data in it, then that's how you will get start charging from the GCP. That's the cloud storage. The next one is the BigQuery. BigQuery is fully managed data warehouse onto the cloud. That's how you can treat it. BigQuery is typically, you can just take the data, whatever format you have it, just store the data and start writing your SQL queries. First you map the data and then start writing the SQL queries. It is, you can think of infinite scalable. You don't have to worry about provisioning the instances in the backend, or you don't have to worry about managing the instances or the processors to do analytics or run the queries. Everything is managed for you. It is fully managed service from Google Cloud Platform. From cloud engineer side, you are not managing any instances. You are just monitoring the usage, the charges, right? How much you are getting charged, what are those queries, if at all some queries are getting failed, how you troubleshoot it with BigQuery. So all of that you manage besides managing the platform, not even instance, not even hardware. So that is the data warehouse onto the cloud. You can do analytics, dashboarding. It's no operations platform, as I said, sync for all your BI reports, and it's EDW, Enterprise Data Warehouse onto the cloud. If you go here, so if you look at BigQuery is not a storage option, right? Or it is not as a normal database and storage service. It is under big data. If you go here, welcome to Google Cloud Console. You can actually manage queries. I don't have any data set actually to run the queries, but you can just have a data set and run the queries. If at all you are using the existing database, which is like in terabytes, please be check. Make sure that you are not using too much, or you're not firing too many queries, because this can get you very expensive. And when we look at the detail, we'll talk about that, but make sure that you're firing a query to limited database so that you are not charged that much. That's the BigQuery. It's a data warehouse in cloud. The next one is data store. This is, you can think of document database. So if you have structured data in the form of document, right, or JSON, and you want to store it, and you can map the real-time examples of MongoDB to data store, because that's what that is another example of document DB. That is where the use case you can map between these two. Typically it is used for hierarchical data, durable key value data store. You can, as an example, you can think of storing user profile, product catalog, or game state. You can store document data and semi-structured application data as well. So typically this is used for the very tiny use case you can think of is user profile, right? If there are user for your web application and you are storing multiple attributes of that particular user data, you just store it and then retrieve it once user is logging in, right? And you want to have that very low latency data pool, and that's where you can use data store or the MongoDB in other implementations, right? So that is where You just create a document, and that particular document has all the attributes whatever you require to present the user profile. And that's it. Either you can do that, or you can just store the game state. Game state is in the form of multiple attributes of that particular game, having different structures in it, and it is a JSON format. If you don't know the JSON format, you don't have to worry about that too much right now. But you can think of it like it is a document storage as a data store. If you go to console, you can see cloud data store as a storage option. And entities, you can think of entities mapped to let me go here. I just wanted to give you an example to you. So database is getting created, and this you will not be charged for just the database analysis until you store the data inside it and you start performing query on top of it. I think this will take some time, but we'll continue our discussion on this one in the detail section. Persistent disk. Persistent disk is it's a block storage which usually attached to the virtual machines, and you can think of virtual machine has got two options. One is the local storage as well as persistent disk. You can use it for taking snapshot of data backup. It is rapid, durable backup running in virtual machine. For running your virtual machine, you can have persistent disk shared across multiple virtual machines. It is a block storage for Google Compute Engine or Google Kubernetes Engine, but at the same time, you need to make sure that you understand the context, right? Persistent disk is a network attached storage for your virtual machines. So it is like a NAS in traditional world, which you can attach it to any virtual machines, and you can detach it from that particular virtual machine. Memory stored. This is the caching solution which we have it in Google Cloud Platform for retrieval. It is mainly a ready space implementation. You can go up to 30 GB to 300 GBs of data in memory, having 12 Gbps of speed, and it has got sub-millisecond data access latency. Cloud Data Proc, this is, you can think of it's either the Spark or Hadoop clusters inside the cloud. So why do you use this implementation versus your own Spark and Hadoop in virtual machine? Again, the benefits are same. Like if at all you are installing the Hadoop or Spark clusters inside Google Cloud Platform or your own premises, you have to maintain the hardware, you have to maintain the operating system, plus the clusters, its sizing, and the nodes or capacity, right? In Cloud Data Proc, you don't have to manage anything. So everything is managed by Hadoop, by Google Cloud Platform, and it is available for you to use it. You just launch the cluster and use it, and if you don't need it, you just decommission the cluster. So what it is available out of Dataproc? Spark. You can use analytics. You can have ETL and batch, and Hadoop for batch processing. More importantly, if you don't know Hadoop and Spark, Hadoop is enterprise data warehouse you can think of, and it's a part of big data. We have actually Hadoop implementations in multiple enterprises to store as an enterprise data warehouse, and you can fire query. It is distributed file system in nutshell, right? Spark, whereas it's a streaming more towards the real-time processing or analytics engine, and you can launch either Hadoop or Spark out of Dataproc. If I go here and go to big data, you can go to Dataproc and clusters. First, enable APIs. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So API is enabled. You can just click on, I think it is still doing it, create cluster. And there you can go ahead and create. You can give the name, you can define where it should be, whether it is global or regional in nature. You can specify the zones, cluster mode, the way you want to have it, whether it is single node, one master, inside that there is worker, or standard one master in nodes or with a high availability. And this is usually preferred in the production loads. The machine types which you want to use it for those nodes, the storage, right, worker node, machine type and storage, right, this is what you configure it. And you can just click create and it will create the cluster for you. Going back again, data flow. Data flow is actually either you stream or batch data ETL transformation tool. This is Apache Beam implementation in the cloud and carries the same benefits as we had it for Dataproc. Use cases, you can use it for fraud detection, financial services, IoT analytics, manufacturing, healthcare and logistics, personalized user experience in gaming, clickstream, point of sale or segmentation analysis in retail. So this is, we'll talk about the architecture more in detail in the next section, but this data flow is it's a ETL engine, and you can either use stream facility from the ETL engine to inject the data, or you can do the batch mode of data transformation. You can go here and you can launch the services in big data. Let me go here. Data flow. Try data flow. You can just go ahead and use different API interfaces to execute the jobs. How you can do that, we'll actually do it in the detail section, but this is where you can actually go and try data flow. Cloud Data Lab. Data Lab is the tool for data exploration, analysis, visualization, and machine learning. So what it means is you can use the data from the backend or from BigQuery, and you can visualize data in the graphic format. So the use cases for the Data Lab typically is data visualization. It is integrated with the GCP database as a backend, so you don't have to do additional plugging in the module. It supports IPython or Jupyter notebook format, and it is used in machine learning mostly. For Data Lab, we do not have any services directly which you can use it in. Let me go here. So if you look at the Google console, you do not have any service which is called Data Lab. You go here, storage, stack driver, you don't have anything here as a Data Lab. What you need to do is, how you can access Data Lab is you can go to Google Cloud Platform Data Lab. And you can go ahead and click on Launch Cloud Data Lab. If you go here, you'll understand that the Data Lab is not the straightforward service offering. What you need to do is you need to create a Data Lab instance. And once you create the Data Lab instance, you will be able to browse and write your queries into Data Lab. So that's the Data Lab. It is visualization tool for database on the GCP as a backend. The next service is Cloud PubSub. PubSub is fast memory caching, that's what they say, but it is, in nutshell, it is an integration tool. So you have any client coming in and talking to any other service. It's a integration or messaging framework which can be used so that you isolate any failures in any of the application. The real-time use cases, or the real use cases for Cloud PubSub is it's real-time messaging. It has got at least once delivery, exactly once processing. It decouples the system, different systems, and it's a serverless and highly scalable service. Typically, PubSub, if you start creating the publisher and messenger, publisher and subscriber, you don't need to worry about provisioning the hardware resources or software components for it. This is fully managed service from Google, and you don't need to manage any infrastructure for it. You just need to just go ahead and use it. So let's just go ahead and look at, and this is one of the exam topic, if you understand, what are different use cases for different, the database and storage service, and when you will use what. And this is typically a summary, right? This is no more beta anymore, the Cloud Spanner. So we have, App Engine Memcache. So App Engine can directly have Memcache, and you can use that Memcache for application level caching. The use cases for that is you want to store the game state or user sessions. In relation, we have two different options. One is Cloud SQL and second one is the Cloud Spanner. In Cloud SQL, you can launch MySQL as well as PostgreSQL instances. It is good for web frameworks and the use case such as CMS or e-commerce. Cloud Spanner, this is fully grown or in-house grown by Google, and this is horizontally scalable, globally available database service. It's again a RDBMS. You can use this again for all RDBMS purposes with highly scalable, highly available service. You can use this for user metadata, ad, finance, or MarTech, or any other use case which RDBMS highly scalable database is required. In NoSQL, we have two services. One is Cloud Data Store, and that is the hierarchical mobile web. You can think of that as the use case, and you can map this to MongoDB as we discussed earlier. You can store user profile or game state in Cloud Store. Cloud Bigtable, though, is you can think of HBase implementation in Google Cloud. You can have high read and write use cases, typically ad tech, financial, or IoT, and this is mainly a columnar database. For object storage, that's where you want to store the static data or the binary data, like static files, which usually doesn't get changed, or you want to store images or videos like that. So that's where you use cloud storage. BigQuery, it's a IDW or data warehouse in the cloud without management of the platform. And this is the decision tree, and decision tree talks about when you need to use what service, right? Because it is so much complex. We'll just start with this one. Is your data structured data? If the data is not structured and you do not need mobile SDK, you are just using the cloud storage as a backend, right? To store your file in int format or images or videos. If at all the data is data required for mobile SDK, that's where you use Firebase. If your data is structured, then you have all the options which is like used for structured database, like Cloud Spanner and SQL for relational databases. Cloud Data Store for non-relational database, but the structured database, and which you want to use it using web framework or any other real-time work. If at all you have some requirement towards data warehousing, that's where you use BigQuery. And if at all you need low latency solution from the data warehousing or analytics, you'll use columnar database like Bigtable. Other options, there are multiple other options which are available for you to use it. This really does not really matter for you as a cloud engineer exam, but you want to go ahead and look at that, why you will use all those different databases. Out of all other topics in this particular section, there is a specific call out for cloud storage classes, and this is related to the cloud storage. There are different storage classes, and we are going to look at this in detail in cloud storage in next section. But in nutshell, what it means is there are 4 different storage classes. One is multi-regional, second one is regional, third one is nearline, and fourth one is core line. The common scenarios to use multi-regional, the content stored and delivery business continuity for highest availability of frequently accessed data. That's where you will use multi-regional storage class. Regional storage class to store the data for analytics and compute within the region, and this is very important. We'll talk about it. Why you use regional versus multi-regional. Nearline and core line, this is used for archival or infrequent accesses. These are some of the additional thoughts around it. What is the storage cost? What is the access fees for all those different storage classes? But we'll talk about this in more detail in next section about the cloud storage. This ends our database service overview. If you have any questions on database and storage service, please let me know. Otherwise, you can move to the next section. Thank you. Planning and configuring cloud solution networking service, and this is one of the 3 core service that we have available on Google Cloud Platform. Like other services, right, computing platform as well as database and storage service, networking service is also very important, and very important for this certification as well, because you manage all the resources, all the cloud resources in terms of database or the computing resources, and you connect them with each other, or you can even protect those resources using the networking services. You can create VPC, that is global data center or virtual data center, onto the public cloud environment. You can have load balancers, firewalls, routers, subnetworks, content delivery network, etc., as a part of networking service. This is networking service is highly divided into 3 different categories. One is the global load balancer or the load balancer. We'll get into details of what are those different load balancers that we can use it in next chapter. VPC and subnet, that's where you create virtual private network onto public cloud environment, and we'll talk about firewall, VPN, and interconnections between them. And then we have another supplementary service, that is DNS and CDN. DNS is domain name service, and CDN is content delivery network. We'll talk about it, what are those and why those are important for us as a business. So in nutshell, from the Google, we have these different icons, I would say, as a services for us to look at. One is Cloud VPC. This is virtual private cloud interconnect to connect your premises with Google Cloud. Cloud load balancer, Cloud CDN, and Cloud DNS. So why, how those services are grouped together, right, and used, right? In applications, you use the load balancer, and that those load balancers should support HTTP, TCP traffic, SSL traffic, UDP traffic, and that's the load balancer part. In application, you use CDN for the content caching, and DNS for your domain name registration, like google.com as a domain name, right? The second one is the virtual network, and that's the VPC, and this is purely you can think of your own data center, global data center on public cloud. So you can protect your own resources, whether it is the computer in the cloud, or virtual machine in the cloud, or databases instances onto the cloud. You create those within the network so that no one can go ahead and access it without your permission. Access control, definitely you put forward access control rules to have access to your network. And then hybrid cloud, and this is where if at all you have hybrid cloud environment, like your own database, your own data center, as well as you want to utilize GCP, as a elastic scaling services for your internet facing application. That's where you do have hybrid connections, right? So with hybrid connection, and this is interconnect, this will tell you how you can connect your premises, your data center with Google Cloud platform. So this is purely the overview of network services. As a part of your job, like as a cloud engineer, you need to make sure that you understand each and every component, and this is very much emphasizing for your job because you are managing network into the cloud. If you look at other certifications like developer, they don't really that much bothered about the network, but they really care about the load balancers, CDN or DNS. But all other thing, it is your duty to manage it on the cloud. So it is important for you to pass the exam. So when you look at the network, we saw this already. Google has made large investment in submarine cable, like the green lines which you see it. That is where it is shared fiber optic cables. But the blue line, if you look at, that is Google's own network. And somewhere I heard that this Google own network carries more than 40% of global internet traffic. Look at YouTube as a service, right? That only carries so much of traffic, video traffic into the network, right? In the globe. So these blue lines is Google's own network, and this is the backbone which you have it. Whenever you are creating the network or your private network using Google's data center, you have this backbone available for you to use it, and this is fiber optic network, so it is very fast for you to use it. What is the innovation which Google has done it, right? Over past so many years. So if you look at the traditional TCP traffic, it was assumed that if there are packet losses, it is because of the network congestion. But with the BBR, and that's where Google came up with their own idea of having the faster network bandwidth, where because all this particular network is their own network and they control what data and how data is passed. So they know that there is no network congestion, right? And you cannot just go ahead and assume that you need to throttle or lower down the bandwidth so that the data is transferred successfully. And as per Google's analysis, it is 2,700 times better and faster than any, the traditional network. And that's what it makes even Google differentiated from other cloud provider like AWS, Azure, or, Alibaba. So I'm not actually getting in details of what is BBR is. You can just go ahead and look at this. I'll try to make sure that this slide is available for you. But in nutshell, what is it is bottleneck bandwidth and round trip propagation time, and is the new congestion control algorithm which Google has developed so that they can transfer the data very fast. Let's look at the individual services that we have in Google Cloud Network that you need to learn, understand, provision it. In this particular chapter, we'll just go through high-level thoughts around it. We'll not get a deep dive into individual services, but let's look at high level, right? Cloud VPC. Cloud VPC is the managed networking functionality for Google Cloud Platform and its services. That's where you can go ahead and create your own public. I won't say actually public. It's a private network into Google Cloud Platform. So Google has data centers spread across all the globe, right? You can create a network which will connect your resources deployed in Europe, Asia, and US, and you can connect them with each other, and you can isolate this particular components or the GCP resources from others using the VPC, and that's the virtual private cloud in Google platform. So using VPC, what you can do, you can build private global data center like field without managing hardware or building it from scratch. You can configure subnet, firewalls, routes, and peering, and that is your traditional way of doing networking. You can monitor using the flow log, and this is very important. We will get into it in the next section about details of VPC, but flow log will help you how the traffic is being routed in your components and who is accessing it, and that's the network flow log. And it is global, shareable, expandable by design, so you don't have to manage any resources for the VPC. Everything is managed for you, and it is SDN, so there is no bottleneck. If at all your router has got a considerable amount of traffic in it, there are chances that it will fail, or there will be bottlenecks if at all those routers are physical equipments, right? In this case, in Google's network, it is not a physical network, it is software defined network, so it scales based on your requirement, based on the traffic, and that is the USP for you to go ahead and create the VPC. I want to go ahead and get into the console and want to show you how you can go ahead and create a network. You can go to networking. If you come here and go to networking, right, VPC, and you can create the network here. Sorry, I'm in wrong account. So if you're looking at this one, you can go to so let me show you where you can go and create the network. Okay, you can go to networking and VPC network, and this is where you can create the network. You can see the default network is already created for you, and that is available for your resources. The routes are created, subnetworks are created, but you can go ahead and create your own network. I'll go ahead and talk about this, what is default network and what is your custom network, but this is where you can just go and create your virtual private, I would say, data center or the network, right? So that's the VPC. Cloud interconnect. So if you have a your own data center, or you're working for an organization and they have their own data center and they want to use some of the services from Google Cloud Platform, right? And that's where you want to connect your data center or the services with the Google Cloud Platform, and that's where cloud interconnect applications will come in, and this will actually let you connect your data center to the cloud. For different use cases, you have different options, but that's what it is. Interconnect is to connect your premises with the Google Cloud Platform. What are the benefits plus features of Google Cloud Interconnect? It is low latency, highly available service. It has got dedicated and partner connection option. It supports RFC 1918 network spaces, and you can have direct pipe from the private data center to the Google, and that is the benefit for having cloud interconnect. The way you can go ahead and create cloud interconnect is, again, you can go to network and you can have interconnection, right? You can just go ahead and get it started. The next one is external peering, and this external peering is the peering which you use it to connect your cloud services, right? This is so external peering as well as the interconnect has got plus and minus benefits. We'll get into details of why do we use one versus another one in next section, wherein we'll look at details. Otherwise you will not understand what is the core essence of these two. In external peering also you have direct versus partner peering option available. You can connect via VPN interconnect for low ingress fees, and that's the external peering. The next option that we have is Cloud VPN, and VPN, this is, you can think of, or you can map it to your own traditional networking concept. You have VPN connectivity created with the tokens. Earlier we used to have this particular tokens, right? But you can have two different facilities connected via VPN connectivity. The advantage with VPN is it has got a SLA, so you can define the SLA, and SLA is maintained for the VPN connection. You can connect site to site. It supports cloud router, and we'll talk about what is cloud router in next section, but it supports cloud router. You just need to keep that in mind for now. And you can secure traffic. With earlier, like direct peering, you probably may not have option to secure your traffic, but with Cloud VPN, you can secure or encrypt the traffic while in transit, right? You can go here and you can go and create VPN connections as a new VPN connections. You can provide different parameters to it, and that's how you can create a VPN connection. This is the decision tree for you to choose one particular networking versus the other one, purely in the context when you want to connect your on-premise with Google Cloud Platform, right? So let's talk about it. Do you need access to private compute resources on GCP? If you do not need, you just want to have access to your to the resources, and you want to reduce the ingress fees, that's where you use this peering, right? So you do not need private access, you do not need interconnection between your own network with the GCP, and that is what it means is like your one machine on your on-premises wants to talk to machine inside the GCP. That's where you use this particular route and not this one, okay? Do you need connection to G Suite? Yes. You meet Google's peering requirement. So there are specific peering requirements. So you should be available in Google's POP location, and that's where you can do direct connection. Otherwise, you can go via partner peering or carrier peering. If you need or you want to exchange your network addresses from GCP versus on-premises, that's where you took this particular route. Do you encrypt the sensitive information at the application level? That's where, if at all you are doing that, that's where you choose this route. Otherwise, you need to go for Cloud VPN, because Cloud VPN provides you encryption mechanism or security mechanism, which usually direct interconnect, partner interconnect will not provide you. So if there is application level encryption available and you are doing it, you don't need to worry about whether in transit there is encryption. Then you can just go ahead and use these services. Otherwise, use Cloud VPN. So can you meet Google's one of the conditions? Yes. Then you can use direct interconnection or partner interconnection. If at all you do not qualify, then definitely you need to go with the partner. Do you need 10 GB pipe or more? That's where you use direct interconnections. If you still qualify for Google's requirement, but you do not need, you probably need say 5 GB pipe, right? That's where you go with partner interconnection. So these are the basic requirement or the decision tree which you map it. What do you want to do it? And when I said interconnection means you want to connect to your premises, your data center with Google Cloud Platform, and then this particular decision tree gets applicable. If you do not have your own infrastructure locally, everything is in the Google, then you do not need to worry about the interconnection at all. Cloud load balancer, this is more towards the developer uses it or your application uses it. Like you have this particular machine facing outward to your DNS, right? And you have multiple services in the backend, and you want to have the load balancer configured here. that's where cloud, Google's cloud load balancer, on they say global load balancer, comes in a play. This is again a SDN driven, so it is not a physical box which may fail based on your traffic. This is software driven, and this scales according to your traffic, right? And you don't need to worry about the infrastructure behind it. It is managed service from Google Cloud Platform. It supports single anycast IP, and we'll talk about what is single anycast IP in detail section. It supports almost all the protocols in the market, scalable software defined network, as I said, and it does intelligent routing, and I'll talk about it, what is intelligent routing, in this section itself in next chapter, where I'll just talk about what are different load balancing options that we have available and what do we mean by intelligent routing. The next service is DNS service, and I think probably we know what do we mean by DNS service or domain name service. It is actually, it will take your name and map it to your IP address, and there are so many operators or providers in the market who does this. It's the same. It will give your it will give you a name for your IP for the backend IP or vice versa. It is reliable, resilient, low latency DNS serving from Google worldwide network, and the important part is it is 100% uptime, SLA guaranteed. It supports private zones, it supports DNS forwarding, and it is cost effective. And we'll talk about this in the next section itself, because even though they have considered cloud DNS as a part of this particular section, but we are going to cover this in detail in the next section. What is Cloud CDN? Cloud CDN is it's a content delivery network, and you can think of your services, the backend services has got some images, right, in your virtual machine, or your cloud storage has some images which you want to deliver it to the customer's handset or tablet or web browser, right? But the usage is very high, which you know in advance, and that's why what you want to do is you don't want to flood the storage bucket or the virtual machines in the backend. What you want to do is you want to cache that information near to the customer, and that's where cloud CDN concepts come in. It is low latency, low cost content delivery network using Google's global network, and I'll talk about this where so there are POP locations which support CDN, and those are the caching locations for us to use it. What you can do with CDN, you can actually do logging. It supports virtual machine and cloud storage as a backend. You can do invalidation request, but there are some restrictions. We'll talk about that. And it supports anycast IP. That's it for this as an overview section of networking. If at all you have any questions on networking, just let me know. I'm going to cover little bit more about the load balancer, how it works, and what is the purpose of load balancer in next chapter in this particular section itself. Thank you. In this section, let's go ahead and understand what are GCP interfaces which are available for you to use it. These interfaces, which means how you can interact with Google Cloud Platform using which tools. So the first one is Google Cloud Console, and this is the UI or the front end, which is web UI or the mobile app UI, using which you can interact with the Google Cloud Platform. We are going to get into details into this section, but that's the first one. The second one is command line interface, where you use your gcloud command or BigQuery command or gsutil command. So that is your command line interface, and in that command line interface you have two different utilities which you can use it. The first one is Cloud SDK and the second one is Cloud Shell. And the third one is API libraries, and these are the REST endpoints which you can use it to call from your programming interface. You can include that into Python or Java or any other programming interface, or you can use a Postman to hit a REST point URL, or you can use the simple utility called curl to interface with the Google Cloud Platform. So this is typically API, and primarily used inside your programming language. So if you divide the whole aspect into the list, the first one is the console. Console again has a mobile app, so that is again another interface. There are plus and minuses in this too. The third one is Cloud Shell. Again, the interface, command line interface, SDK, command line interface, but this gets installed on your laptop or computer, and we need to actually go through the installation step for SDK, and we are going to do that in the next section. The Cloud API, and that's the command line interface. It is, you cannot just interact with Cloud API using your command line. You can do that with the curl utility, but that's not the whole purpose of Cloud API. So let's go ahead and understand the Cloud Console in the next chapter. Thanks. Cloud Console, this is the interface which you can use it to interface with Google Cloud Platform in the UI format. And here I just logged into Google Cloud Platform with my trial account. And if you come here, this is your home page. You will get the complete summary of what is available and what is not available. You can see the project information, what is the project and all of that. We are going to see it anyways, but you'll get the project information. You will get the resources information. So currently I have 3 versions of App Engine, 1 Cloud Storage Bucket, 1 BigQuery dataset. You will have the traces if at all you configured it. And then there are kickstart guides or getting started guide. You can do API Explorer. You can go ahead and run around APIs. You can test those API. You can deploy pre-built solutions like Cloud Launcher. You can do monitoring. You can take a quick VM quick start. You can actually just go ahead and launch the VM or Cloud Function. So this is the getting started or quick start guide. Here is the API response that are available, whatever APIs which we have requested. And here are some dashboards which are available. Currently my App Engine is not running, so you do not have any request responses. The status, if you go here, it says all services are normal. You can actually switch to dashboard and you can see if there are any disruptions. You can think there are some issues here, right? On 20th and 23rd, 22 to 23rd, but this is the whole dashboard which you have it. You can access billing and manage billing out of Google Console. You can do error reporting, and if there are any news out of Google Cloud Platform, and documentation. So this will point to the documentation. If you go here, if you click here, you can go to any services which you want. As an example, you can go to say compute engine resources and you can launch VM here, right? Or you can go to billing, you can manage billing, you can set up alerts and all of that configuration. You can do that from here, and we are going in details of all this in subsequent sections. But using Google Cloud Platform Console, you can launch, decommission all those services, and it is very user friendly and you can access it through UI. So this is Google Cloud Console. So here are some of the features. It's a web admin UI. You can do resource management out of UI, DevOps on the go. So it has got a mobile app, but we are going to see that in separate chapter. You can do secure administration out of console, and you can get the data insight. We saw, your error reporting or the latency, you can get it out of Google Cloud Console. And here are some of the list which is there in the Google documentation as well, which you can go through. That's it for Google Console. I don't think there are so many questions out of Google Cloud Console. This is for your information. Thank you. Google Cloud Shell is the shell which you can use it out of Google Console, and this is another interface, and it's a CLI, it's a command line interface. Let me go back and show you from where you can launch on the shell. This is my console. You can just click this particular button to activate a shell. So it's getting provisioned. So now shell is launched. You have all those utility which are required to interact with the Google, like gcloud command. So you have gcloud command, you have BigQuery, you can BigQuery, you can do gsutil, and this is for cloud storage bucket. So you have everything installed in your console, and this is very good to get it started. If you do not want to install Cloud SDK, this is the first thing. If you want to interact or try your Google Cloud Platform commands, you can actually go ahead and open this in new window as a full screen mode. You see that in full screen, or you can actually you can customize this terminal. You want to have different colors, right? Or fonts or something like that. You can add additional sessions. The good part of this one is if you install or run your local application here as a sandbox, you can actually see the web preview from here, right? If you click here, and I don't have anything running right now, but I can click on this and just you will get the response from here. I do not have anything currently running, but you will see this when we have a App Engine demo. So that's the Google Cloud Shell. Some of the features you can do. It's an admin machine. You can think of you can't actually use it for your own application deployment. You'll have full power or access from anywhere. Secure and fully authenticated, pre-installed and up to date. So all the libraries which are there, which you are using, including gcloud command, everything is up to date. It is developer ready, and it has got a 5 GB persistent disk in it, so you can store your local file. And you can already see that there are some of my folders and directories which are lying there for my demos. It's a web browser access. Using the web browser, you can run commands, so you do not need to install anything. It comes with 5 GB persistent storage. It is secure. Unless and until you log in, you will not be able to access it. And you will have all the developers tools which are required to deploy any applications into Google Cloud Platform using Cloud Shell. So if you look at what it provides, you will have shell interpreter, bash, sh, Linux utilities to install libraries if you want to have it, cloud SDKs, so gcloud, App Engine SDK, and it's a sandbox, gsutil, text editors. You have Emacs, Vim, and Nano, build packs, Gradle, and all those. These are already available out of the shell, which you can just go ahead and use it. And this is, you can think of, it's like command line interface just to go, right? You can go ahead and do one thing here. If you come back again, you can actually do the Explorer, File Explorer, and this is, you can think of Windows Explorer like field. So all your directories will be listed. You can even create your own files here or modify the files here, right? And you can go and save the files. So this is, again, if you don't want to play or you don't know how to use the Vim or Nano, you can actually use this browser as well. But I do not prefer this as much. Because I just like Linux command line utilities to edit the files. That's it for Cloud Shell, guys. If you have any questions on Cloud Shell, let me know. Otherwise, you can move to the next lecture. Thanks. Cloud SDK actually it's again a CLI, command line utility, and this does gets installed onto your laptop. So it is, you can think of shell in your laptop. We are going to install Cloud SDK in the next section because it is required as a part of this particular code structure or the certification. So Cloud SDK, typically it's the utility which you install on your laptop and do so many things with Cloud SDK. Let me go back to the documentation itself and show you. Where is my console? Yes. Cloud SDK. Okay, so using cloud, and this does gets installed. As I said, you can do Windows or Linux installation, but once you install, you will have all the capabilities of your cloud shell in your own laptop. Okay, so the high level tool, gcloud, inbuilt inside cloud SDK, gsutil for cloud storage. You can use it from SDK, so you do not need to install anything else. BigQuery tool, kubectl for Kubernetes cluster, and it does get integrates with your PowerShell command, so you do not need to install any other environment. It does comes with the client libraries, cloud client libraries, or API libraries, which you can directly use it, or you can optionally install some other component which you need it. But this has got ready-made tools, these tools, and you do not need to manage anything outside it. We are going to get into demo of this, how you install it and how you can initiate a particular project, or you can create a default environment with authentication in next section for the cloud SDK. That's it, guys, for this particular lecture. If you have any questions, let me know. Otherwise, you can move to the next lecture. We already saw Cloud SDK. Cloud SDK is CLI, command line interface, and the utility which you install on your laptop or computer. Let's go ahead and download it and install it. Let me go here. I just went into Cloud SDK quick start or download. You can go there. So if you have this one, Cloud SDK, it has detected my operating system. I can go here. So I already have a project. You just need to download it. Single user mode. And all. So you will get an option whether you want to install beta commands. I said yes. So installation has been done now. It says complete. I had to pause the video to complete the installation to save the time. So let me say next, finish. Okay, so that is done. Let me go ahead and do CMD here. And let me put gcloud. So the first command which you need to do is, or to initiate your gcloud command is, you need to do, I just put that in here. You need to initialize it. Let me go ahead and initialize my interface. So you must log in to continue. Would you like to log in? I would say yes. So it is asking me your user ID password to log in. I just said yes. Allow. So it is logged in as my user ID, and then let me go ahead and, so these are my list of projects that are available for me to select it as a default project. One, enter. Now it is going to ask me, do you want to set up default zone for compute? I'm just going to say default yes, and I'm going to choose US West 1A, and that is 13. So everything is set up now. Let me go ahead and put forward gcloud, and these are the options. If I say compute instance list, instances, and list, it will give me the list of. So this is how you can install and set up gcloud command. Along with gcloud you will have gsutils as well. The path is not set up, but gsutil as well as BigQuery. Okay, so that's the utility which you will get it by default out of Cloud SDK. That's it for Cloud SDK, guys. If you have any questions, you can ask me, or otherwise move to the next lecture. Thanks. Cloud APIs. This is, you can think of, you can use it while in your programming, and it's a REST endpoint. It's a REST API which you can use it. Let me go to the console and show you how you can explore different APIs. Let me go back. If I go to the Cloud Console as a home page, you can go here, explore and enable APIs. And here you will see what are APIs executed in your duration. This one, you can actually change that duration or download those transactions. But let me go ahead and show you one example. I went inside Compute Engine APIs. In here, you will get the information, how many usage for your Compute Engine APIs, but you can go and try in API Explorer. So here, this is a sandbox. You can try different APIs. I can go here and let me try one Compute Engine instance create. So instance list, let me try this one. So what it needs project ID and the zone. Let me go here and get my project ID. This is my project ID. And zone, which zone I'm referring, and I just need to put any zone. I'll just give US underscore hyphen east 1 as a zone. So it'll ask me permissions, which user, what it says, unknown zone. Okay, let me give 1A. I just gave the region US East 1 B. It says unknown zone. Let me go here and see if I have any virtual machine running there. So it says US East 1B. Just copy paste. So here you go, the outcome, the instance name, what it's kind of compute instance 1, it's a name, and it will give all the details of IP addresses and all the information. So I have this IP address. And so API Explorer is really a good tool to explore these APIs, and you can query it and you can get the information out, and you can see the sample outcome. This is what you will get it in your programming interface. And this is the API request which you are putting it. That's the Cloud API, guys. If you have any questions on Cloud API, let me know. It's a programming interface. That's what you need to remember. If at all you want to try it, you can use API Explorer. That is another reminder. And if at all there is any questions, it will be around this one for you. If you want to try, say, REST endpoints, what is the option which you want to use it, right? And API Explorer is one of the option that you will get it, which you need to select it. That's it as the interfaces, guys. We are going to get into Cloud SDK installation in next section anyways. But if you have any questions on theory part, let me know. Otherwise, you can move to the next section. Thanks. Hello, welcome to this lecture. This lecture is a part of Masterclass Cloud Computing for architects, designers, developers, and sys operations. Are you excited? You should be, because we are going to take a deep dive into Compute Engine. And this is the first lecture in deploying and implementing cloud solutions as a detail of service. As we already know, Compute Engine is infrastructure as a service from Google Cloud Platform. It's a virtual machine or the computer in the cloud you can think of. Computing service is one of the three core services, just to remind you, out of networking, database and storage and computing platform. And in computing platform, virtual machine is one of the three services. Other options available are code and container and serverless. So as I said, virtual machine or computing service is infrastructure as a service where you manage all the components, you have full access on the hardware. Before we dive into the Compute Engine, let's go ahead and take a look at what is the syllabus says for understanding compute service. So here you go. So what we are going to see, deploying and implementing Compute Engine resources like launching instances, creating autoscale instance group, using an instance template, generating, uploading SSH, configuring VM for Stackdriver, monitoring and logging, accessing compute code and requesting inquiries, installing Stackdriver agent and monitoring and logging. Other theoretical part which we need is managing VM like SSH RDP, and this is more you can think of demo, but to understand this demo you need to have understanding on what do we mean by snapshot or images, right? Instance group. All of that I'm going to cover in the theory lecture here in this section. Going back, Compute Engine. We understand that why do we use Compute Engine? So there are requirements which we can't easily containerized and you want to use existing VM images onto the cloud. Application that needs OS level changes. You want to host application without rewriting it, and you want to have a full control of infrastructure, direct accessing network and other compute resources. And that's the power of Compute Engine. You want to spin off Compute Engine. Let's go ahead and take a look at components of Compute Engine. Disk are required for you to install operating system or to process the data or to store the local data in VMs. Images are the images using which you launch a Compute Engine. Networks, we saw that there are the networks which are global in nature. You need to attach the network so that you can isolate a particular virtual machine from access by someone else. At the same time, you need to make sure that you have access to the virtual machine using the network. You do configure firewalls, and firewall you can attach it to the virtual machine as well. We'll see how to do that. Addresses like IP address, internal and external versus DNS. Regions and zones. So we saw region. What is region, right? So they have divided the whole geography into regions, and in one particular region you have multiple zones, so that if at all one zone goes down, you have another zone who can actually take the request, customer request. So zone is physical location, and how you attach or select a particular zone, we'll see that. Instances, how you manage the instances. Load balancer, auto scaling, instance template, instance groups. That's what we are going to see it. Some of the features of Compute Engine, typically in the context of Google Cloud Platform. It supports sub-minute billing. What do we mean by that? So you'll be charged, if at all you are spinning the instance for say 30 seconds, you'll be charged for minimum 1 minute. But then after, if at all you are using that particular instance for 1 minute and 2 seconds, you will be charged for 62 seconds only, right? And that's the sub-minute billing. Globally scoped images. So the images which it supports is globally scoped. It supports CDN, Content Delivery Network, and we are going to have a demo about it. Disk performance, you can have local disk or RAM disk for higher performance for your VMs. It supports high network performance because you have Google Fiber Optic network which supports virtual machines. Live migration. Live migration means actually when there are maintenance happening on the physical server, physical hardware, then your virtual machine gets live migrated to another physical hardware, but it is seamless to seamless performance to you, and we are going to talk and look at it. It supports auto restart if at all some problem happened and it is not scheduled stop or start. It will try to restart the virtual machine. Machine right sizing, and this is a very good actually use case of compute engine, that you can configure your number of CPUs and GBs of RAM the way you want to have it, and this is only available I think in Google. If you go to AWS, you have predefined set of machines which you can use it. Automatic discount, so you have multiple kind of discounts available to you. One is committed savings, sustained use discount, inferred instances, frame table, virtual machine. We'll talk about that in the discount section. It supports Linux and Windows. It has predefined as well as custom machine types option, and it supports global load balancing. It supports auto scaling. And that's it. So these are the features of compute engine, and this will impact going ahead when we configure those virtual machines in the demo. Let's look at some of the performance attribute for compute engine. And typically, when you want to look at how your compute engine is performing, what are the parameters you need to consider? The first one is processor family, and this is, you can think of standard. If at all you are launching say one instance in Asia, one particular zone, and it has got one or two type of processor family, you don't have choice. So but this is one factor you can think of in computing performance. The processor family defines whether the processor is 2 gigahertz, 2.2 gigahertz, or 2.5 gigahertz. So some of the processor family here: Haswell, Broadwell, Ivy Bridge, Sandy Bridge processors. The next one, and which you control and you define, is vCPUs. So typically, what do you mean by vCPU versus actual physical CPU, right? vCPU, if at all you just generalize it as a virtual CPU, and if you want to map it, the capacity, so 2 vCPUs, which means 1 CPU in the physical hardware. Let's look at the network throughput, right? So what is the network throughput? How actually it varies? So typically the network throughput is dependent on the number of vCPUs in your virtual machine. And that is, per vCPU, you will get 2 Gbps of network bandwidth. So if you spin up an instance which has got 4 vCPUs, you will get 8 Gbps as a bandwidth network attached to it, and you can go up to 16 Gbps with 8 core machines, but you cannot actually go beyond that. Even if you increase the number of CPUs after 8 cores, it is not going to increase the network throughput beyond 16 Gbps. The last aspect here is based disk IO, how performant the disk IO is, right? And that's where you will need to think about how you can increase the disk IO. For disk IO, there are different parameters which you can look at, and whether it is SSD or magnetic disk, that is one differentiating factor. What size of that particular disk is, right? So there are these two parameters, and we are going to look at what is that. We said it supports two machines, Linux and Windows, and to connect, spin up Linux machine or Windows machine, what are the parameters which you look at? Typically, the license cost, if there is any, like Red Hat Linux or any other license, that is included in your cost per minute cost, per second cost, right? The connection, the way you do connection, if at all you want to directly SSH using the console, you do not require any key. You just log in and then click on SSH and then you will get connected. You can SSH it from Cloud Shell. You can SSH via Cloud SDK, and that is from your desktop or third-party client. And that's where you need a key. Otherwise, you'll not be able to connect it. But typically, if at all you're connecting it from outside that console, then you will need to open TCP/22. That's the protocol in firewall. If you have not opened it, then you will not be able to connect. Your connection will be refused. So that's the Linux. You will have a key to connect it from outside, and we are going to see that in demo. For Windows, anyways, the license for Windows is also included, so you don't have to register your instance. Everything is included. You will have a RDP support like SSH in Linux case, using any RDP client, PowerShell. You need to set the password, and this is very important. Even if you want to connect it from the console, you need to have a password to connect to the instance. The firewall rule it should allow is 3389, and this is compulsory for your Windows machines. Machine types, there are 4-5, let's look at 4-5 machine types in GC, because there is one custom type, and then custom you have flexibility to configure your own. So standard machine type, in this standard machine type, it is balance of CPU plus memory. You can think of like 1 vCPU, you will get 3.75 GBs of RAM, and that is your the standard machine. And this is a balanced. So this is, if you don't know how you are going to use it, you just spin off standard machine. The CPU you want it, and memory will be configured for you. And you can go from 1 CPU to 64 or 96 based on your need in standard. The second one is shared core, and this is very small when you have very light load. And you can think, if you look at here, it is like 0.2 or 20% of your CPU. In F1, you will have 0.6 GB, which is 600 MBs of RAM, and you can attach a disk the way you want to have it. But this is how you represent F1 machines. And then you have a G1 machine. In that, you have 60% of CPU, it's not even 1 vCPU, and 1.7 GBs of RAM that it supports. F1 allows micro busting, and what that means, if at all that particular physical hardware has a capacity, and your application or the programs need additional capacity for some point in time when your program is running at that time, it can go beyond your 0.2 CPU usage to say 0.3 or 0.4. We don't know that, but that F1 allows microbusting for certain loads. The next one is high CPU machines, and this is where you have higher CPU as compared to memory. If you look at the standard one, it has got, for 1 CPU vCPU, you have 3.75 GBs of RAM. But in case of high CPU, you will get, for one particular CPU, you have, because you do not need that much memory, so it is 0.9 GB, and you can go in multiples of that. But in this kind of machine, the CPU starts from 2 and onwards. In standard, it can actually, you can start with 1 and onward, but in this machine, you can actually start from 2 and onwards. And there are some restrictions, right? You cannot go below 1 GB in these standard machines. And that's why they have, I think, restrictions. High memory, this is actually the vice versa of high CPU, wherein you have, for 1 CPU, you have 6.5 GB of memory. And this is where you are processing too much of data in RAM, and that's where you need. In this case also, you will have CPUs from 2 to 64 or 96 based on your need and based on what you have availability. Typically, the machines are represented like this if at all you are using the standard ones. But there is a third one, third machine type, wherein you can actually go you can define your own CPU and you can define your own RAM, right? You can mix and match between all these configurations, right? Whatever it is available. And there is actually button here, and you can extend the memory as well, and you can go up to 624, but I'll show you how to do that. I just wanted to actually show you another one. This is Ultra Machines, and they recently came up with this particular machine type. In these Ultra Machines, you have vCPU 40, and you can go up to like 961 memory. So these Ultra Machines are special requests you can think of, and you can use it. They must be very expensive. If you look at number of disk, you can attach it. Any of these machines or Ultra Machines, you can go up to 16 persistent disk attachment and up to 64 terabytes of total memory, which you can attach it to any machine. Let's go ahead and look at this in console. How does it look like? I just need to change an account. Okay, let me go here. So if you want to spin off virtual machine, just go to home and compute engine and the first tab. Click on create. You don't have to spin off the machine to explore. So you can provide the instance name the way you want to have it. The region, this is where you specify which location you want to launch it. I'm just selecting, say, by default region here, default zone here. I'm not changing it. And you can see your monthly estimate for whatever definition, whatever configuration you have it, right? And this is where you can go ahead and change and define your configuration. So either micro, small, which is G machines, right? F and G machine, and then standard machine. If you go down, high memory machines, high memory, high CPU, and ultra machines, right? This is, I think this is the new machine. They have it like mega machine, mega memory, somewhere like 1.4 terabytes of memory with 96 vCPUs. But this is ultra machines. I'm just keeping whatever I have it. Yeah, you can even customize it. That's the third one, right? So you can define like I need 4 CPUs and then I need, say, 24, and this is based on your calculation, right? 6.5 GB per CPU, and that's how you have 26 GB. But you can just click on this one, and now you can go so much high, 624. I just captured that particular number from this itself. As I said, you can even use or configure CPU platform, right? Let me go here, basic flow, first one, and CPU platform automatic. And this is where, you know, you can map CPU platform, and that will give you the speed, right, which I mentioned. So if I go here, so depends on the CPU platform, you will have speed. Let me go to vCPU and okay. I don't see any configuration here, how the network bandwidth impact, but that's the written one. Let me go other aspect. So if you want to attach GPUs, you can attach GPU, and you can you can choose which model you want to have it, I'm just saying none here right now. Then if you want to deploy container, we'll talk about this in next section. And then service account. On default service account, I have service account which I can just use it. App engine. So I have these 3 service accounts. I'm just keeping it as a default. When you log in or create a virtual machine, when you enable the APIs, then you will have service account which is by default. Then firewalls, right? You can add tags, firewall tags. I don't want to say anything here. If at all you want to have HTTP traffic, you can do that. You can add firewall rules if at all you want to have it. You just need to click that, details page. That's where you can do management. You can just give some tag, labels, automatic startup script. If you want to say run one particular script when you start the instance, this particular script will be executed. If you want to say start Apache instance or Tomcat instance in the backend, you can install, you can have the startup script here. We'll see this in demo. Okay. Metadata, you can assign metadata to the instance. Preemptibility, on and off, you can do it. I'll talk about that later. Automatic restart when machine is in maintenance mode. This is where you can switch on and off if at all multiple, if at all for some reason, hardware failure or any reason, right? Your machine stop, you can set it automatic restart on or off. And host maintenance, what you want to do, you want to actually live migrate your virtual machine. Live migrate means you migrate your instance from one particular physical hardware to another one without stopping it, and somehow magically Google does it. You will see some performance bottleneck if at all you are hitting like 80% CPUs, but if at all you are using say 10, 15 or 20% of your CPU and memory, you will not feel the downtime as such. And that was management. If I go to other tabs like security, like if you want to encrypt your data, you can, if you want to secure boot, you want to use TPM or integrity monitor, you can configure it here. We'll talk about all of this in security section. The disk, as I said, you can have the disk, and that disk you can have operating system installed or the database installed. You can go to networking, you can attach the networking here. I just have one particular networking, so I don't need to worry about that right now. Sole tenancy, we'll talk about sole tenancy, but sole tenancy is like, if you go here, just understand sole tenancy. What do you mean by that, right? This is a physical box, physical hardware machine, right? Sole tenancy means you will have your virtual machines running in one particular hardware and no one else is actually using that hardware. That is what, so this particular server is dedicated to you only, and that's the sole tenancy. I go back. Okay, that's it as a basic. I will continue onto compute engine, the next aspect like GPUs and everything in next lecture. Thank you.
Let's look at quickly what I'm going to cover in this demo. It's load balancing, auto scaling, high availability. This illustration is something you can see in coming versions of your lectures wherever it is applicable. Consider this particular representation wherein we have website, and that website is used by users across the US. I'm just considering the US use case, and which you can ultimately replicate it to the different regions across the globe. You have the subscriber base which is located in East. You have subscriber base or users which are in Central. You have users which are in West, and then Cloud DNS which takes your request, forward it to the load balancer, which you can say HTTP load balancer here, and then the request gets routed to your implementation, and your implementation could be container engine, app engine, cloud function, probably your compute engine, and consider here only the compute engine part, because individual implementation like container works differently than app engine than cloud functions. So consider a plain simple case here. Assume that all the instances are the compute engine instances, and understand how load balancing works. All the requests which gets into the cloud DNS are forwarded to the load balancer, and load balancer distribute those requests across multiple instances to service those requests. Load balancer makes the decision where to forward those requests to the backend services. When the users from the central wants to use the service or website, here the request goes to DNS forwarded to load balancer. Load balancer magically makes a decision and understand this particular customer is coming from US Central, and it should be served from the nearest location for him, and which is like the implementation which is based in US Central, and the requests are forwarded to the compute engine which is in the central. Consider the next case where the users from the east trying to access the website or the service. The request gets into cloud DNS, gets into load balancer, and those requests are forwarded to the nearest region or zone for that particular user. In case of east, it should be somewhere in your east of US. Similar fashion, if you have the customers actually accessing the service from west, the request is forwarded to the west implementation of your services. So this is how cloud load balancer makes the decision and forward the request intelligently to the backend service. But hold on, cloud load balancer use another parameters or input to make this decision. Let's look at this. So you can see, consider looking at the speed of these particular requests which are getting into the different services in different regions. You see there are considerable amount of requests from west to the west compute engine. So as the requests are continuously going high, the server is getting busy and busy and busy, and that's where auto scaling will play important role. But hold on, here is the catch. If load balancer checks a particular container engine is somewhat full, and it needs to be reduced the traffic from those particular instances, it will route to the next available instance or the region, which is, you can say, some of the requests are which are red dots. The requests are getting into the US Central as well at the same time. In the meantime, autoscaling makes the decision and decides that they need to create another instances because there is considerable amount of traffic, and it kicks in additional instances to serve the particular traffic in US West zone. That's the autoscaling. And then magically everything works, and then the additional instances also start getting the traffic from the US West users. So this is autoscaling plus the cloud load balancer's decision what to forward and where to forward the request. By this time, you know that how load balancing works and autoscaling works. Now understand how about HA, high availability. So consider a case here. If something goes out, right? If you are not able to reach to US Central, and just replicating or using the regions concept here, but you can think of central region is one particular zone. Now the link to the zone is gone, or because of some reason it is not available. What will happen is your request, which are, you can see the yellow dots which are going there. Now cloud load balancer with the health check understand that there is no connection to the central zone, and then it makes a decision to forward the request to some of the instances which are available to or near to them. And in this particular case it is east, because west is somewhat far for them to send the request, so it will send the request to east, and that's HA. So you understand, cloud load balancer makes a decision where to forward the request. It has a health check which checks if the instances are healthy to send the or forward the request. It also checks whether the instance is not too busy to service it, or otherwise it will forward it to some other location which is nearest to them. I hope you understand in a high level how load balancing, auto scaling, and HU works.
Let's go ahead and create some virtual machines to understand how we can actually go ahead and create those. This is Google Console to have this. Let me actually just get into the console straight away. Once you get into the console, you will see the dashboard. It will show you the projects which is currently selected. You can actually see multiple projects whatever you have created in this particular account. You will have this information. You can actually see if there are any resources which you have created, but there are none right now, so you don't see any. There are multiple actually documents, or you can say guide. You can actually use this guide to create the virtual machines straight away. You can see the APIs traffic currently which you are using, and there are different items here which we already saw it in the console's overview. Let me go straight to the Google Compute Engine. So this is what I have right now. I just cleaned up each and every the resources in this particular project to create fresh. Let me go ahead and create one virtual machine. So you can actually see that it will need instance name here. I can actually type in any name which I want. So you can actually see that it is only lowercase letters, numbers, and hyphens. So let me put web 01 instance name. The zone, as we discussed earlier, ultimately all those data centers are divided into regions and ultimately the zones. So if you look at there are multiple zones here wherein I can go ahead and create as we are actually talking right now. These are the zones which are available. So the first letter you can actually see that Asia East 1, that's the region, and then there are multiple zones in East 1 which is A, B, and C. Likewise we have multiple zones, so the regions and corresponding zones associated right now which is available for this particular resource to create. So let me just pick any of this zone, and you can actually see the price, and these are estimates for monthly the virtual machine usage. You can actually go ahead and change different zone, and you will see the price is also getting changed. So you can actually very well get that the price for this particular resource, which is instance virtual machine, is getting changed, or is dependent on the zone which you are actually creating, or in fact it is the region which you are creating, and then based on the region the pricing will get changed. So which says effectively hourly rate 3 cents, 3.4 cents. Let us try to search a very cost effective option if we can get. So you can see in Asia it's $28 per month, in Australia it's 34, which is somewhat expensive, in Europe 27, Europe West $31, US Central 24, East 27, and West 24 again. So East or West you can actually just go ahead and create. You can actually select the machine type which you want to create. So you can go ahead and select the available machine types. As we discussed already, there are multiple machine types, which is like first one is the standard, per CPU there is 3.75 GB of memory available, and you can go up to 64 virtual CPUs and up to 240 memory in the standard. Then you have high memory. In this particular machine type, you have per CPU there is a 6.5 GBs, and you don't have option to select one virtual CPU. You need to actually select 2 or onwards or more, and you can go up to 64 CPUs and 416 GB of RAM. And then you have high CPU machines, which are per CPU there is 0.9 GB of memory which is available. So, and you can again cannot select one virtual CPU here as of now. You need to select at least 2 to go ahead and start those instances. You can actually see, you can go up to 64 virtual CPUs with 57 GB of RAMs. You can actually select all those configurations or combinations based on your need, whether you need more memory to cache some data, or you need more processing or the CPUs to do, say, computational analysis or something. So based on your requirement, you can go ahead and choose. But there are, besides these, there are other two, which is shared CPU. The CPU itself is shared between the instances, and you have memory options between 0.6 GB to 1.7 memory. One is F1 micro and G1 small. In F1 micro, we saw that using F1 micro, you can actually go ahead and so the instance itself will be it can throttle to the higher speed based on the requirement. Let me go ahead and choose, say, F1 micro. For that, 0.6 GB memory is already selected, right? Let me just go ahead and customize this one and see what I can get. So if I come out of virtual CPU, which is 1, it is giving me 3.75 GB, which is standard machine. And yeah, I cannot actually go below 1 GB, or I cannot go below 6.5. 6.5 is the machine where you have high memory machines, you can say, option. So it will get increase. You can actually select any combination of those. The best thing about this particular combination is you can very well see what is monthly cost, what is estimated monthly cost. Definitely, if you go ahead and terminate these instances and then use it again, or stop those instances for certain time and use it again, there will be proration happen. But this is high level running cost for the machine, considering 730 hours per month. Then you have option actually to select based on the CPUs and the memory. Let me actually go ahead and select. You can actually go ahead and select the CPU platform. Okay, so you can't actually I think select the CPU platform if you are in custom. Yeah, but let me just go ahead and choose one of these particular machine and try to select, because there are constraints and which you can't use certain platforms. Okay, so I think in US West, let me choose US Central and let me see what platforms. Yeah, so it is not actually based on the CPUs. Definitely there are constraints to select the CPUs, but it is locked to the zone. That particular zone, if you have the CPU platforms available like Skylake, Broadwell or Hashwell, that is available for US Central. US is, let me see what are options. Only one. US West, that's what we saw, only one. Let me go ahead and select central, and if I select the central for 7.5 GB RAM, 2 vCPUs, and I want to select Ivory Bridge, the price for those two or any of these platform is going, at least currently showing it is same for me. I can go ahead and add GPUs. So GPU aren't available in this particular zone or zone you selected. I need to actually change the zone. Let me choose US East. Okay, that's not there in US East as well. Okay, now in US West you have option to choose GPUs, and I can choose 2 GPUs of this one. You can say the cost is going tremendously high. So if I take out GPU, it's showing somewhere around $50, but if I choose any of the GPU, the cost goes too much high. Somewhere around $500 per GPU is what they are charging per month, right? So let me actually not select this one right now. A boot disk, this is where actually you can choose predefined images. If you want to use the public images right now, you can actually choose it from the images, and the options available, as I said, Windows and Linux, whatever it is used right now in the market. You can actually choose either the Windows machine or Debian Linux as an example, right? Or you can actually choose any of the image application image, like this one is Windows Server 2012, or you can actually select from any image. I don't have any image right now, I cleared everything. I don't have snapshot, I don't have existing disk at all to choose the image from. The boot disk, actually you have a choice to either select the magnetic disk or SSDs, and price actually changes based on what you choose it, and in fact this speed is associated to that gets changed. Let me go ahead and just keep the magnetic disk and continue, select. So that's the Debian Linux 8 which I have selected. It is asking me service account. I want to actually select the same thing. I don't want to actually do too much ifs and buts. I want to select all HTTPs, and let me go ahead and with all defaults create. So this will take, I think, some moment to get that particular server started. Yeah, the instance is ready now, and there is an internal IP address which you can actually use it for internal load balancer or any other internal communications or rules. For external IP, that's where you can see this IP is assigned, and you can actually very well go ahead and ping that particular IP if the traffic is allowed. You have multiple options to actually connect to this particular instance. One is through your SSH browser right now, the way we are doing it, or there are multiple. You can even connect it with PuTTY. For PuTTY there is another a process. We'll talk that in detail in subsequent lecture, but this is the way. Let me just go ahead and connect with SSH. See, it is connected. You have full access to the machine right now. If you want to actually do SU, which is root access, you can just very well go ahead and do it. So that way you can access. We'll see more features on this one in subsequent lecture. So if you are ready, let's go ahead and jump on to the next lecture. Thank you. In this particular demo, I want to create or show you how to create a Windows virtual machine and how to connect the instance. So if I click on create instance, I can say web win 01. I want to create that in West because it's somewhat cheaper. I want to change this image to the Windows. One thing to note here is if you select some of the Windows machines, it will show you, the size for the persistence is 50 GB, and for some other it will show you, for some other which I tried, it's 32 GB. That is even fine. So right, for some other it is saying that 50 GB is required, so at least 32 GB is required for some Windows instance. That's the take here. I'm just selecting whatever it is required, but I want to create the SSD for this particular instance because it is taking too long time to create the instance, and I want to even change this particular instance for the demo purpose because it was taking too long time to create the instance with the small configurations. So I want to allow everything here. So SSH key, actually it's a, you can say, similar process, but I'm not creating any SSH key here or attaching it. I want actually preamtable. So if I switch it on, the price should go down drastically. Okay, so before I switch it off, it was $112, and if I switch it on now, it is showing me $78. This price is there because I have relatively considered big machine. If I select a smaller machine, it is $41. Let me choose the big one because I want to create this video as much as fast I can do it. So let me create it. So the instance is being created. Let me pause the video for some moment so that we'll come back once the instance is up and running. So the instance is ready. So it has got external IP address, internal IP address. Yeah, I can go ahead and create instance group out of this particular instance. Let me just go ahead and do RDP to the particular instance. It's asking me password. So I have password already created, but I think it should reject because this particular password which I had created was for the other instance. So before you guys go ahead and connect to this particular instance, you need to reset the password for this particular instance. So set password for this instance. So this is the user. And this is my password, right? I can use this password to connect it, but keep this in mind. It takes actually some time for you guys to get this particular instance. If the instance is very small, you need to wait for certain, at least some time for your password to get reflected in that particular instance because it takes some more time. So the instance is coming up now. or it's at least getting connected. And you have option to either disconnect, minimize, send alt control del. This is Chrome's you can say extension for RDP, which I'm using it right now. I have created this particular instance, but this is not unfortunately which I created with the desktop. So whenever you do RDP, you will be able to connect this particular instance, but you will not be able to see the full desktop here. So I have created another instance which we are going to do RDP in a short while once the instance is ready. I'll pause the video for some time. So the instance which I have created earlier was the server instance, and it does not have the graphics inside it. So in the meantime, what I did is I created another instance, Windows instance. Let me set the password for this one as well. Copy the password. Just need to actually save this password. You need it while you are connecting it. So close and do RDP to this instance. It's connecting. So it takes a while for smaller instance to get that password reset, whatever we did. Either you can actually wait for some time to get that reflected, or you have another option actually just to go ahead and stop the instance and start again. So that way you will have all the updates for password into the instance. So the instance is coming up. So the instance is started now. I have resetted the password as well, and I have the password for this particular instance. Let me do the RDP. So I think there is some issue which this particular guy is guiding me on certificate, and the instance here is 97. Delete certificate. Okay. So connect again. Password. Continue. Yeah, see, it's now connecting to my Windows instance which I have created. The earlier instance which I had created was only the server version, so it has got no actually the UI as such. as a desktop. I have created another one with the UI, choosing another image. So let's go ahead and understand if this particular instance has got a internet connection right now or not. Once it pops up, first time usually actually it takes time. It will not be too much for the second time onwards, because for Windows it has to set up the profile and everything when you are logging in for the first time. So this is Internet Explorer. Okay, I understood the risk. So let me put google.com. Continue. I hope it is coming in. This is warning message. Yeah, see, we have google.com. So let me actually try Chrome, try to actually install Chrome here. I don't want actually this warning message to come up, so I want to go ahead and download Chrome. Let me see if it is allowing me to install that here. And you can actually configure the Windows option here if you want to do it. It's taking somewhat time. Probably the instance which I have chosen is this guy is still setting up the options. I think let me go ahead and pause the video here. Yeah, means ultimately I can go ahead and browse internet, so which is good news. And then by default Google actually gives you Google Cloud, the shell. You can run gcloud commands inside the machine if you want to, right? So that's it for I think the Windows machine, guys. If you have any question on this one, let me know. Otherwise, continue to the next lecture or the demo, into which I'll try to explain. So that's it for the Windows virtual machine, guys. We'll continue our discussion on the virtual machine demo, and next chapter is, or the next demo for us. Hello. Welcome to this lecture. This lecture or the section is a part of Masterclass Cloud Computing for Cloud Architects, Designers, Developers and sys operations. Our main focus is Google Cloud Platform and certifications around it. Are you excited to get into new section altogether? Yes. We are getting into data solutions, and this is the next one after completing our computing service. Database and storage service is one of the 3 core services that are available in any public cloud platform, and it contains the relational database. It contains NoSQL databases like Hadoop, DynamoDB, MongoDB, Spark, Cassandra, and whatnot, right? So that is all database and storage service. Database and storage service, along with AI, divided into 3 different high-level categories. And this division is because of we have new partners like artificial intelligence and big data, and those are the like offerings onto public cloud platform, and that's why we have So database and storage is again one of the 3 offerings that we have in space of say data, big data, and AI. So database and storage contains SQL, NoSQL, database and storage. We have big data offerings like Hadoop, Spark, Apache Beam, like that. And then we have machine learning, and this is altogether separate topic altogether. But we are going to look at machine learning in nutshell as well. So what is that we have on database and storage services? We have Cloud SQL, which is a relational database on cloud. And you can actually launch MySQL as well as PostgreSQL instances in cloud using Cloud SQL out of Google Cloud Platform. Cloud Spanner, it's homegrown relational database management system, horizontally scalable across the globe. Big table, it is, you can think of HBase implementation in cloud, Google Cloud Platform. Data store, you can think MongoDB like implementation in Google Cloud. It's a document DB. And then we have cloud storage. It is an object storage. It is network attached storage. You can think of, you can just store an object into this, and the object could be any static file or images or videos or like that. And then in big data service, we have Cloud BigQuery, Cloud Data Flow, Cloud Data Proc, Data Lab, and PubSub. We are going to see all of these services together. In fact, Cloud PubSub should not be a part of big data service. They have just categorized it inside big data service. It is an integration tier or messaging platform, which we use it for all our messaging needs in public cloud. Let's get into details of what it is expected out of you as a cloud engineer from data side, right? So you need to deploy and implement cloud solution around data space, ensure successful operation of those cloud solution around data services. When we say deploying and implementing data solutions, in nutshell, what they have put forward is initializing data systems with a product like Cloud SQL, data store, BigQuery, Cloud Spanner, Cloud PubSub, all these data services like initializing. So you need to launch instances or initialize the service for you to use it, and then you load the data using command prompt, API transfer, import, export from cloud storage, streaming data to the Cloud PubSub, and this is wherever it is applicable. Okay, this is the part of section 3, deploying and implementing solutions. And as a part of section 4, managing data solutions onto the cloud, you need to execute the queries. Once you have the instance ready, everything is there in the cloud. Now you need to execute the queries, retrieve the data from data instances on all these, estimating cost of BigQuery, backing up, restoring data instances, reviewing job status in cloud data for Cloud Data Proc and BigQuery, moving objects between cloud storage buckets, and this is purely in the context of cloud storage, converting cloud storage bucket between storage classes, setting up lifecycle management policies for the cloud storage, working with management interface in Cloud Console. So all of these are the detailed syllabus, but if you summarize and categorize all those things together, what we are looking at is for Cloud SQL, data store, big table, data proc, and spanner, we need to launch a new instance, create new instance, set up those instance or configure using different parameters, load the data to and read the data from those instances, high availability configuration, backup, replica, and restore configuration. All those are like admin activity, and you have to manage it in the cloud environment. For cloud storage, you're managing buckets, objects, etc. You're managing storage classes and its pricing around it, how you optimize your cost. If you look at BigQuery and data proc, so BigQuery is just managed service, how you schedule a job and execute a job, the process and its life cycle. For data proc, it's a Hadoop and Spark implementation, so how you create Hadoop jobs and Spark job and run it and maintain its life cycle. For Cloud PubSub, it's a messaging platform, and we'll get into demo of this one. We just had a glance of it in computing platform as well, but we are going into details of Cloud PubSub and to create a message and trigger those messages. Data flow, it's purely you can think of not asked especially in the syllabus, but we are going to cover so that you understand. If at all you have any questions, one or two, you should be able to cover that, but we are going to go through that. That's it as a starter, kickstarter for this particular section. If you have any questions, let me know. Let's get started onto Cloud SQL. Thank you. Are you excited to get into details of Cloud SQL? Let's go ahead and get started, okay? So as I said, the Cloud SQL is a part of database and storage service, and database storage service is a part of one of the 3 core services that are available out of any cloud platform. Cloud SQL is part of data and storage out of big data and AI. And it is one of the service that we have available out of data and storage service, and it is part of plain simple data and storage service and not the big data. Let's go ahead and get into it. So Cloud SQL, it is fully managed MySQL and PostgreSQL RDBMS in Google Cloud Platform. Before we get into details of the properties of MySQL, let's go ahead and launch the instance and see how difficult it is. So I'm just logging into the console. Let me go and select project, and it should be in database and storage SQL, and this is Cloud SQL. Cloud SQL, you can either create instance or migrate instance. Let's just go ahead and create. I'm just going to use the default MySQL launch. So it takes instance name. I would say GCP train CE. Password, let me just give the password GCP train CE, and I can actually choose where this particular database instance should reside, right? I'm just going to select US West 1 and A. That's it. I'm not actually going to get into details of it. So it says which version do you want to have it. MySQL, you have 2 different versions. I'm just choosing the latest one. IP, public IP, configure machine type, and I can actually change the standard machine type to something else. Okay, and enable backup and recovery. So backup is by default enabled. Enable binary logging. Logging is also enabled. If you want, you can create a failover replica. I can just click on it, the name of the failover replica, add database flag, and these are like MySQL flags if you want to add it, right? All of this one, I'm not going to do it. Maintenance schedule, I can actually choose the preferred maintenance schedule because Google is doing maintenance, and usually Sundays 12 to 1. I'm fine with that. Okay, anytime. And then if at all I want to create a labels, and these are the labels you can think of. It will go to you can organize based on the labels for all your resources. I'm not going to create right now anything. I'm just going to have all this information and just going to use SSD versus HDD create. So the instance is getting created, and you can see how easy it is actually to get the instance created. I'll come back again in here after completing some of the theories. Okay, let's go ahead and continue our theory part. Okay, Cloud SQL, it is fully managed MySQL and PostgreSQL databases in Google Cloud Platform. All RDBMS requirement based on MySQL or PostgreSQL. That's where you will use it, right? what are the typical workloads? You have ERP, CRM, e-commerce application, geospatial data. This is where you use a relational database management system. You use it for website, blog, CMS or BI applications, and web framework, structured data or OLTP workload. And this is where you use MySQL, and you can actually use it from Google Cloud Platform. Some of the properties of Cloud SQL: it is simple, fully managed. It has got 99.95 availability, and this is amazing availability in Google Cloud Platform. Performance and scalability: you can go up to 10 terabytes of storage capacity with 25,000 IOPS and 208 GBs of RAM with 32 processor core per instance. And this is, you can think it's like huge. If you are large corporate, you can go for the large instance of MySQL or PostgreSQL. It is reliable and secure because you have all the security which are available from Google Cloud Platform. You can use it for this MySQL instances. It is reliable because of the uptime, plus you can have read replica and it does failover, and we are going to see that shortly. Some of the properties of MySQL: it is fully managed community edition database in cloud. Data is encrypted by default in REST. Support SSL with Cloud SQL proxy. Replication between multiple zones with auto failure. You can have import and export support. Auto on-demand backup and point-in-time recovery. Instance cloning. You have integration with Stackdriver logging and monitoring. PostgreSQL, it's again a fully managed PostgreSQL 9.6 database in the cloud, and these versions actually keep changing, so don't just blame me if at all this version changed if you're looking at this video. Data is encrypted at rest. By default, it supports SSL with Cloud SQL proxy, replication between zones with auto failure, import export using SQL dump, auto and on-demand backup, instance cloning, integration with Stackdriver logging and monitoring. And we are going to see all these concepts in theory as well as in demo. Okay. The next thing, some of the thoughts which you need to make sure that or you understand that when considering Cloud SQL versus MySQL. Okay. Some of the not supported MySQL statement like load data in file, select the SQL statement into out file, select SQL statement into dump file, install plugin, uninstall plugin because it is managed for you and you do not have access to the software, create function with some name, right? And that is not allowed. Second generation unsupported, create table with select statement, create temporary table, statement inside transactions, and transactions or statement that update both transactional and non-transactional database. So all of these are like database features, guys, and some of those unsupported feature becomes supported shortly because that is what it happened to my other course as well. All these platforms are continuously evolving, right? And some of the things which are not supported right now, which they have mentioned it, in some point in time it is supported, and you do not have questions according to those fragmented functionalities. Keep that in mind. Okay. Unsupported functions, load file, check unsupported client program features as well, if at all you want to discover more. For PostgreSQL, so these are valid, like replication is valid, but it is not supported in PostgreSQL. High availability configuration, point in time recovery, import export via CSV files. Some of the performance thing which I want to talk about it, and then we'll shift to high availability and replica. Performance is dependent on multiple factors here. Okay. So the performance of any database you can think of as, because it is continuously hitting the storage, that depends on the size. And this is typically even if you look at the compute service as well, the type of storage which you choose, like SSD is high performance, low latency storage that you have. If you choose HDD, then your IOPS goes down, right? Input output, this thing goes down. The network throughput, definitely we saw this already. Network throughput is dependent on the CPU which you choose, and if you have one particular CPU, then you will have lower bandwidth, and if you go up, then it changes, and we are going to see that shortly. But let me go ahead and show it to you, the network throughput. Okay, so this is still getting created. I'll go ahead and try show you the bandwidth, network throughput, and performance. I'll just mark my second test, no password, or I'll just click generate. I want to actually go and show the configuration, machine type, and everything. Okay, you see here. So the network throughput in MBs per second. So currently, if with whatever CPU I have, it's 250. If I change it to say high memory machines, select it goes 500. Change something very big. Okay, 64 CPU machine, and this is, you can think of, it's like 2000 MBs per second, and this is the throughput which you get, and which really impacts your database performance. The second thing is the type of disk that you have. So if you have SSD and 10 GB, so the IOPS that you have is, for read it's like 800, and writes it's 480. Okay, so this is size actually, not IOPS. IOPS is in here. So read you will get 300, and writes you will get 300. If you change the size of disk, that gets, the numbers get changed. Okay, at the same time, keeping the same size, if I switch to HDD, this has got lower performance, and the price, so you'll get actually good amount of space with the same price that of SSD, lesser price that of SSD. So that is what you need to make a trade-off, what you want to do. Okay, earlier it was, when I recorded the theory, you can actually saw that I was allowed only 32 CPUs, but now if I see this, you can go up to 64 CPUs and 416 GB of RAM. So this is performance characteristic which you look at. So one is the network performance. Second one is IOPS for the storage. Read replica. Typically, what you need to do is, if at all say your web application or any application is writing and reading it from master continuously, right, you are prone to failure of this, either zone connectivity or problems in your database, right? And for that you will create one failover, so that if at all this goes down because of some reason, you can read the data from the failover replica. And then even if this master is on, you can still go ahead and read it from failover replica. Plus you can actually go ahead and get the data from read replica. Okay, the synchronization of data is from master to the failover is semi-synchronous replica. Okay, that's how it synchronizes data. But as if you look at, if you have the applications which needs considerable amount of reads continuously for your BI systems or any other system, what you can do is you can create multiple read replicas, and that's how you can get really good transaction or throughput out of database instances. We have actually created some of the read replica, the failover replica out of this one. Let me go ahead and create read replica as well. I can go ahead and edit this particular instance. Okay, I can import data, export data, restart, stop, delete, clone, and I can just fail over the operations. Okay, I can go here, databases. So I have this particular database information, and I can go to replica, and I can say create read replica. I'm just giving by default name, whatever it is, and the region and the zone. If you look at the zone, it's a US West one. If I go here and see where it is located, US West 1A. Okay, this is the zone which the database is located. I can go to replica US West 1A. If I create a read replica US West 1A, I can actually choose any other zone if I have to, but usually it will keep the data near to the original. So zone is physical location, right? And it will try to keep the data near to that particular zone. When you are creating the failure, if you look at it, is in another zone in the same region, and it's not in the same. Let me go ahead and just create the replica. Enough about the theory. I am just leaving the name as is and the same zone. Replica is getting created. So if you have multiple reads, and that's where you don't want to impact the master where it is writing and reading, you can use read replica and you can scale it. And there is no limit on creating read replicas. Once we create this one, we will see, you can create the multiple. Going back here, so this is how the read replica will be used. So if at all, say if you want to failover, right, failover because of some system problems, this database goes down, then you can use it. Or you can actually say, I want to failover directly onto this particular instance. You can do that using the command here, or you can actually do that via command prompt. Let me go ahead and just do a failover. I can do GCP train. I want to use this trigger failover. So what it will do is it will take this as a failover and West B as a master. Okay, that is what it will change. Let's come back again here after moving further. So you can have a read replica up a cloud instance. You can have the read replica inside the cloud instance. Benefits: additional read capacity, analytics target, and you can go here and identify more information about the read replica. External read replica. What is this? So the Cloud SQL instance will have the master will be in your Google Cloud Platform, but you can have the read replica created outside your Google Cloud Platform. Maybe it's in your own data center, right? And that's how you can actually create external read replica. What it will do, it will reduce the latency for external connection. As an example, if you consider the case where you have Cloud SQL running and serving your customers from the web, okay, you want to hit either the same so read replica sitting inside the cloud instance for your analytics. But what you can actually do that is, if at all you have the analytics running inside your own data center, what you can do is you can create read replica inside your data center, and data will get synced continuously, and you can run analytics onto the read replica which is there in your data center. And that's how you can use the read replica on premises. External master, and this is where consider a case, right, where you have a master where you have a MySQL instance in your own data center, but you want to create a failover that into Google Cloud Platform. As an example, so if something happens to your data center MySQL instance, you can use the read replica which will be there onto Cloud SQL, which is GCP again, and you can connect to that particular database quickly, the way you want to manage it, right? If at all something happens to your on-premise MySQL instance, you can definitely have read replica sitting inside your own data center. But if at all something happens to that instance, you want to have some backup in the cloud where it is safe, right? You can switch it to that. Typically, if you look at, you have my external master, and this is the case. The Cloud SQL read replica continuously synced the data back here, and this is like database server on premises, and data continuously gets synced up into read replica. Going back again to our instances, Okay, so you can see the failover complete or not complete. So it has, I think, triggered the failover. I don't think it is complete yet. Okay, so we triggered that operation to create the failover. I think it is not yet complete, but that's how you can actually trigger the failover. You can actually go ahead and check the database operations which you ask for, create, read, replica, backup, and that is what it is. Like, these are database operations that we have it. Replicas, we have read replicas created. Backup, you can actually create a backup. I said you can create backup by default, but you can create your own backup. My own backup, create, and this will get stored into cloud storage. Okay, so it is creating a backup. Database, we went there. You have only 2 users. You can go ahead and create the users here. So as because backup is getting created, so this may take some time for us to enable. And this is overall your information. This is your public IP, and you can, if you want, you can connect it via your gcloud command or your MySQL workbench. We are going to get into that. View operations, if there are any operations, you can actually edit the instance. I will show you how to edit an instance. So you can change, if at all you think that this N1 standard is not sufficient, you can select any other instance and you can say save, and this will actually instance will restart, save and restart with the new CPU and the memory which I asked for. Okay, this is public IP address. And you can explore more the way you want to have it. Let me go ahead and schedule maintenance, right? So this is the window which we have asked for as a schedule maintenance, whatever they are doing, maybe patching MySQL, patching OS underneath. A very important part is the connections. Connections, we said you can have these connections, or you can actually enable private, and that's where you can go in edit and you can change that. You can have app engine connections, SSL connections if you want. We are going to get into details of this demo. So failover is just running, I guess, still. Yeah, instance is restarting. That's it as a basic concepts as a MySQL, guys. If you have any questions on MySQL, let me know. We will create another demo for PostgreSQL. Thank you. Cloud Spanner, it's a global RDBMS or relational database management system which Google has built it from the ground. Cloud Spanner is one of the database services that are available for us to use it, and it's a RDBMS category. So the database, and so it is a part of database and storage service, Cloud Spanner, this one. So you can think of, we saw Cloud SQL, which is a relational database management system, and that using which you can launch MySQL, PostgreSQL instances. With Cloud Spanner, it's not, you're not actually going to launch any other database. It's a Cloud Spanner is the database which you have it and you can launch it. You cannot take Spanner onto your on-premises environment, so you need to just launch it from the Google itself. Currently, Cloud Spanner is used as a Google's own RDBMS requirement, and it is globally scalable database that we have available. So Cloud Spanner, it is fully managed relational database management system built from ground up, and that is done by Google. All RDBMS requirement, and that is the Spanner's, you can think of use case, ad tech, financial, global supply chain and retail. You can scale plus consistency requirement, and that's where you use Spanner. It is horizontally scalable database that we have available, and we are going to see it. Mission critical applications with high transactions, but at the same time you can say if someone has a global database requirement, that's where you can use Cloud Spanner besides Cloud SQL that we have. Typically, what is the best of both worlds that Spanner is giving it to us? It has got a schema which is there in traditional RDBMS, which is not there in the relational database. You have SQL like syntax, almost all the SQL syntax which is there from relational database is available in Cloud Spanner, which may not be available in some of the NoSQL database. Consistency, strong consistency which you can tune it in Spanner, and in relational database, where in NoSQL you have eventual consistency. Availability, in terms of availability, is high available, horizontally scalable, and automatic replication, whereas traditional RDBMS like MySQL, PostgreSQL, or Oracle, you cannot actually do horizontally scalable. It is fain to failover. You can actually scale vertically, you cannot do horizontally. Replication, it's configurable the way we want to choose it. Definitely NoSQL provides high availability as well as horizontally scalable. As an example, I can give you the DynamoDB or MongoDB or Cassandra. It has highly available clusters that we can use it. Some of the Cloud Spanner use cases, and this is, you can think of the use case or typical use case which you want to understand. Why do we use Cloud Spanner? This is not mandatory for engineers, cloud engineer certification, but it is required for the developer exams and cloud architect exams. So financial trading, inconsistency leads to, and this is before Cloud Spanner, inconsistency lead to potential monetary loss during reconciliation. Global reconciliation replication is a trade-off feasible. Inconsistency lead to incomplete view of a customer, and you can actually map this to the type of database which we are comparing is Oracle is there, say as an example, Oracle is installed in Europe somewhere, right? That is not available in all other so the instance is there in the Europe, and it is not available in US and Asia, right? Whereas Cloud Spanner, actually it can span across multiple regions, and you can have strongly consistent database spanning across the globe, and you can maintain this consistency. You can have unified view of a customer, and you can actually compare that. So all of these thought processes or the use cases which you have it is in comparing the database which resides in one particular region or location, whereas the database which span across multiple regions or locations. Global call centers, eventual and out of touch. It's a real time and up to date. Supply chain management and manufacturing. Supply chain presence, inconsistency, global view, or data must be shipped in batches. And this is where if you want to actually reconcile the data between all other different locations, then you want to reconcile or transform the data into one system, and then that's where you get the single view. With Spanner, you can have global real-time consistent view of which will enable real-time decision making. Telecom and billing, processing capacity limited to finite scale up. Compute resources, scale out, allows improved processing speed. And I don't think this is a problem for many of the telecom providers, because I worked in telecom, but maybe some of the telecom provider may face this. Logistics and transportation, regional reach with many systems glued together, global reach to lower latency and consistency view. Gaming, each server and cluster is own universe, like you need to have different cluster in different regions to provide consistent and fast access to your gamers. Consistent global will to deliver unified experience. E-commerce, limited availability, SLA or no SLA guarantee in practice potential, missed sales. Guaranteed max up to 5 minutes downtime. On paper, like this is the SLA which they have it. This is, you can think of it's like sales pitch or why even spanner exists today. Okay. In nutshell, what you want to see is, the one is regional in nature or zonal in nature. If you map this to the Google Cloud or any public cloud context, and spanner is global in nature. So these are the attributes which are there. I'm not going to get into details, what is valid and what is not valid and why it is not valid. Okay, this is just information purpose. I'm going to share the slides and you can actually go through it. Global scale, it is terabyte scalable and practically infinite, the way you want to have it. Availability, monthly SLA, multi-regional offers 99.999 with downtime less than 5 minutes, and this is monthly SLA. Consistency, purpose to build for external, strong and global transaction consistency. And this, you can think of why they are putting forward this consistency, right? So they have this fiber the network which is actually backbone for the spanner and all other Google services. And the way the speed of the network which they are achieving it, they are saying that even though this database is global in nature, it is still strongly consistent database. In 2018, what we saw, multi-regional admin versus data logging, stack driver integrations, all of these are like in 2018's enhancement. You can commit timestamp, you can have commits timestamp compliance requirements which you can enforce it. So some of the data which are like European Union, it can reside in Europe and like that. Open census integration. You have import and export out of spanner. DML queries also supported and query stat also supported. So all of these enhancement is related to 2018, and that's what we saw. In earlier, when I prepared the other codes, this was not there, you can think of. How this the global spanner look like, right? If you look at, if you create a database and the database actually, as an example here, DB1, right? So DB1 exists in zone 1, it is exists in zone 2, and it is exists in zone 3 as well. Like DB3, it exists in all 3 zones. DB2 exists in all 3 zones, like that. So it can span across multiple zones. That is what we want to say here. The instances, typically, if you look at, if you drill down the DB1 part, right? If you look at DB1 exists table 1, and table 1 is there in all 3 zones. Table 2 is all 3 zones. So consider a case wherein when the update actually goes to, say, zone 2, right? In this particular table 1, what it will do is it will take the updates right into database 1, but at the same time it will hit the other 2 zones, write it there, and then you will get actually feedback back, that the confirmation back, and then that's how you get the confirmation for the commit, and that is how it is strongly consistent database. So consider if at all zone 2 goes out for some reason, what will happen is you can still go ahead and get the data from you can still go ahead and get connected to zone 1, and that's how the data goes to zone 1, and then it will write to zone 3, and then you will get the confirmation back. So what is instance? Instance is the allocation of resource. When you create an instance, you can choose where your data is stored and how many nodes you use it for. Let's go ahead and create one instance in Cloud Spanner. So I'm in storage, and inside storage you have this Cloud Spanner option. So Cloud Spanner is fully managed mission critical relational database. I'm not going to read this, you can just go through it. What you need to give is, you need to give the instance name, GCP train Cloud Spanner instance, You can actually configure regional versus multi-regional nodes. The configuration you can choose it. If you say multi-regional, then it will give you only few options, right? Europe, your Asia, and these 2, 3, and 6 is I think US, and you will get the details about it, right? Northern Virginia, Southern Virginia, like that. So 2 read replicas which are available in US East 4, and 2 read replicas which are available in US East 1, that is South Carolina. Availability is this. So whatever you choose it here, you will get the details out of it. So num6 and all of these, the details about it. If I choose Europe, you can see Belgium and Netherlands. You will have this region, and then there are 2 read-write replica in Europe West and 2 read-write replica in Europe West 4. If you click regional and select one particular region, you will get the information, right? Regional Asia East 1, 3 read replicas in 3 separate zones within Europe Asia East 1. Availability is reduced. So if at all you choose any of the regional ones, you will get 4 nines of availability. If you choose multi-regional, example this one, you will get 5 nines of availability. 5 nines of availability means it is 0.001% not available, right? Which means around 5.4 or something like that minutes in a particular year, the instance may not be available, and that's the SLA guarantee which you will get it. I'm going to select regional, and you can actually just go ahead and choose one. You can define nodes here, okay? And the nodes is the cost factor. So if you increase the node here, like you will get for 100 nodes you will have $90 per hour charges, storage 30 GB per month, okay? If I change the number of nodes, the node cost in terms of processing gets changed, but storage remains same because you are using the same storage. Node guidelines, right? What is the guideline which you have? So each Cloud Spanner node in this configuration can provide up to 10,000 QPS, and that's how you request for a node. If you have only one node, you will get 10,000 QPS of read. This is queries per second, that is read queries per second, or 2000 queries per second of write. So this is or, it's not actually and. So you can actually mix and match of all these queries, and that is what you will get the performance. And the writing single row at 1 KB data per row and 2 terabyte of storage. So you are actually pulling the data from 2 terabyte of storage, and that's the per node performance which you will get it. You may ask a question about you have high your database is suffering, and currently database has got 2 nodes. What is your recommendation, whether you want to increase CPU, memory, what is that you want to do, right? And your answer should be the nodes, if the node is there. For optimal performance of the configuration, we recommend provisioning enough nodes to keep overall CPU utilization under 75%, minimum 3 nodes recommended for production load. Okay, so there is nothing here as such. I can just go ahead and hit create, and it will create a spanner for me. So there is no data yet. So spanner instance is created for me. Okay, I can create database inside the node. I can give GCP spanner demo db spanner db, continue, and this particular name is unique to your GCP project. Define your database schema, add the tables indexes the way you want to have it. It has a text. You can actually give statement to create it. I'm just going to create a database. So now I have a database. So I have instance inside that I have a database, I can create multiple database inside it. I can say create multiple database. I can edit instance. I can say instead of one I can put forward 2, and then cost will be changed like this. You can import the data, you can export data out of it, you can either delete the instance. Okay, so that's the Cloud Spanner in nutshell. This is how you launch the instance. So when you create an instance, you can choose where your data is stored, how many nodes you want. Nodes, typically individual nodes, that's what we saw. Spanner has node to process the data, actual instance. Node provides 10,000 queries per second reads and 2,000 queries per write with single 1 KB, and this is assumption. If at all your size goes high, then probably you'll not get this performance, and the performance will be reduced. And 2 terabytes of storage. Node count defines the number of nodes in the instance. For additional purpose, you can add nodes. Encryption, it automatically encrypts all your data before it actually writes to the disk. Data is automatically and transparently decrypted when you read from the authorized user. There is a concept of interleaved table here, and you can actually have one table sitting inside the other one, like the example here. It does not really matter for you. In here, I can have additional database designing for Spanner as a separate lecture, but it is not really required here. This is the way you can actually go ahead and create the tables. So the table has got fields, and fields has got a type, and then you can use primary key. You can just go ahead and get any select statement from create statement from the internet. Or I can actually just go ahead and copy paste this and create a resource file so that you can just go ahead and create it. Okay. So first one is just a table, single table. Second one is actually the album table, and which sits inside the single table, and you can have a songs table, interleaved parent album. And you can go ahead and create the indexes also. So indexes is also supported. You can create index on the songs with the multiple, it's like cascade index. So the number of spanner nodes in your project is based on regional or multi-regional, the amount of storage that your table and secondary indexes use, the amount of network bandwidth which is used, and this actually translate, you can think of the number of nodes, right? It translates to per node hour rate. Regional, you will have 90 cents, and that's what we saw, to 1.126, depends on the location which you choose. Multi-regional, it can go from 3 to 9. And you can actually go here, I'll show that. Create instance. If I go here, choose multi-regional and select any region, then you will get $3. For Asia, it is more $9 per hour. Okay, so it is different in different region. So $3, $5, and $9. Okay. For the storage, per GB per month, 30 cents to 45 in case of regional, 50 to 90 in case of multi-regional. If you look at here, multi-regional, this is 70 cents. If I choose change the region, it can come up to 50 cents, or it can go up to 90. Okay. In case of regional, it is different. So you will be charged based on amount of network traffic or bandwidth which will be used. Ingress is free. Egress with the same region is free. You need to keep that in mind. Between the regions, you will be charged per GB 1 cent. Intercontinental egress at internet egress rate, and you need to look at the network charges which will be applied in the VPC and the network section. Cloud Spanner and IAM, as because it is ground up build, it is very well integrated in IAM, and you will have different kind of IAM permissions which you can use it. One is instance configuration. You can create a list, get the instance information. The second one is instance operation. You can delete, create, and all that instance operation. You can create a database. This is inside the instance. You are creating, updating database. You are getting the database. You are doing it database operations, or you can even you have permissions for session, like whether you can connect to the instance or not, right, or database or not. So typically, admin is a person, admin database admin is again a person, database reader users can be machines, and viewer again can be a person, and this is primitive roles which are also used. That's it, guys. I can actually go ahead and get another demo created wherein we will go ahead and create the database tables as well. But thank you for this particular. But that's it for this particular lecture, guys. If you have any questions, let me know. Otherwise, you can move to the next lecture. Thanks. Cloud networking. Cloud networking is very much, or you can think of critical service that are available from any cloud providers right now there in the market. We use cloud networking to isolate your resources, cloud resources, from other companies or from public accesses. Let's go ahead and get into details of what is that we have available from Google Cloud Platform. Cloud networking is one of the 3 core services that are available from Google Cloud Platform or any cloud platform to say. In cloud networking, you can create a virtual private cloud. You can have load balancers. You can create firewalls, routes, subnetworks, CDN, as that you are actually using it from your own data center. In a high level, cloud networking divides into 3 different areas. The first one is the load balancer. That's where you take the traffic from your customer and distribute your traffic to the backend services. And we saw this in detail in our computing service. The second one is VPC, and that's where you create the virtual private cloud, which is, you can think of private networks in the cloud, in the global cloud, and you can spin off any resources inside that particular virtual environment or private environment so that others cannot actually access it. So VPC is one, and you have subnetworks, firewall, and VPN created inside the VPC to isolate different environments. But besides that, you go ahead and create a hybrid connectivity. Like if you have your data center and you have some applications running inside your data center, you want to connect your data center with the Google Cloud Platform, and that's where the VPN or the interconnections part also will come, and that is what we are going to see it in VPC as well as VPN or interconnections in this topic. We are also going to see DNS and CDN services. These are also the core services that are available, but those are, you can think of, optional service or additional service which you can use it based on your requirement. But we are going to see this in detail in this particular section. So in nutshell, we are going to see Cloud VPC, which is the network inside the cloud. We are going to see interconnect. Interconnect means connecting your data center with the Google Cloud Platform. We have already seen load balancer. We are going to see CDN, and we are going to see DNS here in this particular section. Cloud VPC. It is managed networking functionality for Google Cloud Platform resources. Using Cloud VPC, you can create a private network. What it means is you can provision your GCP resources, connect them with each other inside the VPC, and isolate them from one another using or creating different VPC or the subnet inside it. You can also define fine-grained networking policies with Google Cloud Platform, on-premises, or other cloud infrastructure. Using VPC, you can think of it as comprehensive set of Google managed capabilities, including granular IP range selection. You can define routes, firewalls, and cloud routers as you are actually doing it in your own premises or your own data center. Let's look at some of the features for VPC. It is built You can build private global data center like field without managing hardware in terms of like hardware switches or routers, or building it on your own. You can have subnet firewalls route, or you can define the peering inside VPC. You can monitor the network connections using flow logs, and it is global, shareable, and expandable by design. So you don't have to provision any resources. It is not a physical device, so that it gets bottlenecks when there is a problem or there is huge bandwidth utilized. It is managed functionality. Everything is managed by Google Cloud Platform, and it scales based on the requirement. So you don't have to worry about the scaling. It is software defined and it is not the hardware. I just wanted to reiterate that. It is possible to provision cloud resources. You can connect them with each other, and you can isolate them. You can create a subnet, and you can even isolate different environment like prod, dev, and test, right? And that is what VPC provides. There are different types of VPCs which are available. One is the default, which is created by default when you have an account. You can create auto mode VPC, or you can do custom mode VPC, and we are going to get into details of that. Some of the features of VPC in Google Cloud Platform: it is global in scope, so it is not specific to region or zones or a data center, right? It supports multi-tenancy. You can have private communication. You can define subnetworks. You can define firewalls. You can define routes. You can have a cloud router for BGP link. You can share the VPC. You can have access control managed via IAM. So in nutshell, VPC is a comprehensive set of, you can think of Google managed networking capabilities, including granular IP address range selection. You can define routes, firewalls, and it is virtual private network on the cloud, and it supports cloud router. And what do we mean by cloud router? We are going to just see it in the next slides. So VPC is a virtual version of traditional physical network that exists within and between your physical data center. So you can think of it is virtual version, and it is software defined, and it is not your physical devices inside your own data center. Each GCP project contains one or more VPC network. VPC is global in nature and allows global VM instances and other resources to communicate with each other via internal private IP addresses. So VPC itself, the concept of VPC itself is global in nature. It is not tied to a particular region or zone. So VPC does not have IP range. So IP range is created within the VPC. You can create different subnetworks, so part of that particular network, and you can attach the IP ranges to those subnetwork. So if you look at the VPC, it is firewalled network, and it has got no IP ranges. It contains subnetworks, and subnetworks has IP ranges. You can have more than one subnetwork in a region for a given VPC. As an example, if at all you are deploying your services into, say, US East, one of the region, you can have multiple environments created there, like dev, stage, performance testing, or UAT, and the production. You can create all of those as a different environments or different subnetworks, and that's the power of subnetworks. Some of the thoughts on project and VPC: all the objects associated with project, definitely, because VPC is contained within a project, so all the objects inside the VPC is also associated to a project. Each project starts with default VPC, and that is default which is created out of it. You don't have to create it, and it is in automate, so everything is created for you. You can go up to 5 networks per project, and this is the limit right now that we have it to create the VPCs. Let's go ahead and get into details of different type of VPCs that are available and its features. The first one is default VPC. So this VPC is created and already there when you have a project. So for each and every project you have default VPC. Subnets are created by default per region, per zone. Internet gateway also created, firewalls also opened between subnets so that all the resources can communicate with each other. Let's go ahead and browse this in the console. So if you go to network and go to VPC network options, you just click on VPC network, and this is the default VPC which is created for you. You don't have to create the VPC, and these VPCs contains subnetworks that are created per region. All the subnetworks are created, the routes are defined for all those subnetworks so that it can talk to each other, and there are firewall rules also created for all increased traffic. There are firewall rules which are created, and you can attach these firewall rules to a particular instance, or you can have it for the whole subnetworks. Let's go back. So that's the default VPC that is created by default for you by Google Platform per project. The second one is auto mode VPC, and this is you can create a VPC here. If I go ahead and say create VPC network, you can either say custom VPC or auto mode VPC. If I say auto mode VPC, then this is what it changes. So you will have subnetworks routes created by default for you, and you do not need to worry about it. When you click on auto, that's where you need to add the subnetwork wherever you want to have it. As an example, right, this one. So I'll go back. So auto mode VPC has got a single subnet per region by default created. It has got fixed /20 CIDR range per subnet. You can expand that up to /16. Default network is auto mode network, and predefined IP ranges are there. So you are not creating any IP ranges. So if you look at this one, automatic, you have these subnet ranges already created, IP ranges already created, and that is by default. Firewall rules already created for you, okay, and the routes also created for you. You do not need to create anything in case of auto mode VPC. If at all you want to disable something, you can just go ahead and disable that. Custom mode VPC, no default subnets are created. If I just go ahead and make this as a custom VPC, let me just create it, custom VPC, and let me say custom, and I can just go ahead without any configuration. I can make dynamic routing rules, whether it is regional or global, and we are going to get in details here, but I'm just leaving it as is now. And you can have DNS policy also. You can just go ahead and create it. So the custom mode VPC is getting created. So it has got no manual, no default subnetworks. Manually created subnetworks can be valid. Any valid RFC 1918 IP range. Range do not have to be contiguous between the subnetworks, because you are defining your own subnetwork ranges, right? And you have full control of IP ranges. Going back here, if you look at this custom mode VPC, does not have any subnetworks, and it is custom, right? No firewalls rules created, no dynamic routing. I can just go ahead and add subnetwork. My subnetwork US West 01, and I can go here US West 1. I can actually define IP ranges. And you can go up to 16 per IP ranges or CIDR ranges. You can have Google private access on or off. You can enable flow logs, and flow logs is very important when you want to audit who is accessing what data, and you want to monitor the network, and that's where flow log will be useful. We'll go ahead and get into it, but I'll just go ahead and add this for now. So it is creating my subnetwork inside custom VPC. It is not yet created, I think. Okay, yeah, it's ready now. So I have subnetworks created, but if you look at firewall rules, none of that is created. So if you look at this network, for this network, we have firewall rules, but no firewall rules created by default for custom network. The routes, if you look at the routes, there are two routes created. One is default gateway to the internet, and one for your subnetwork that is created. So routes are created for the subnetwork which you have it, but not for the other subnetworks which you have not created, or any other region or zones, right? If you want to connect to. So that's the custom VPC. So in VPC, as a summary, if you look at, you can create per project, you can create 5 networks, and that is by default, which is the quota which you get it from Google Cloud Platform. So you can create say prod, dev, stage, and all that network, or based on the department also you can create the network, and you can create different subnetwork to isolate different kind of environment like dev, stage, and prod, right? Those networks are global in nature. It is not tied to one particular region, and you can create any resources in any region within those network. It can talk to each other with the internal network communication, so it does not have to use external IP address to connect to each other or talk to each other. But if you are creating a resources in different network altogether, this communication is the external traffic, and the internet egress charges will be applied for this particular communication. Just need to keep this in mind. So if at all you are creating resources in different region within the network, then it is internal Google internal network, and there are no charges incurred as an internal to the network. There are some cross region charges which is minimum, but it is treated as an internal to the network. But if you are connecting two resources in different network altogether, even though they are in the same region, it is treated as internet egress traffic. Cloud networking, hybrid connectivity. We are going to get into details of the connection between your own premises to your VPC. And we already saw VPC, how you can create your private networking in public cloud environment. Now we are going to see how you can connect that private environment or private network with your own data center, if at all you have it, or your office. So hybrid connectivity, or the connection from your own office to your cloud or your private network, is a part of networking service, and networking service is a part of one of the 3 core services that are available in public cloud environment. We are going to see, we already saw VPC, that's your private networking in cloud. We are going to connect the VPC with your own premises using VPN or interconnections, and we are going to get into details of that right now. So to connect your own premises with GCP, you have multiple options, and you can use based on what is the use case that you have it. So the first option, and this is just copy paste you can think of from Google Cloud Platform. The first option is Google Cloud Interconnect. And what is that? It is so this is required wherein you want to have considerable amount of data exchange between your Google Cloud Platform and your own office. not your end customers, but your own office or your own data center, and that's where you use cloud interconnect. We are going to get into details of interconnect shortly, but wanted to just give you a high level overview. The other option that you have if you do not want to have dedicated connection is cloud VPN. And this is, you can think of it's like traditional VPN or IPsec VPN, which you can use it over public internet. There is no physical connection exists when you are using cloud VPN. It is just going via public internet. And why you use it? You do not have actually the use case to connect your cloud interconnect, or to have a dedicated pipe from the GCP VPC to your own premises. And that's where you will start with the cloud VPN. It is low cost as compared to interconnect, and it has got its own benefit and disadvantage as well. But that's the second service. The third one is the peering, and this is not purely a part of Google Cloud Platform, but you can think of peering is required when you want to connect your Google Cloud Google platform like G Suite applications. You want to access all other Google services, and you want to take advantage of reducing ingress fee, and that's where you use peering. You have multiple options there in peering, as a direct peering and carrier peering, and we are going to see the differences in all of those shortly. So the first one is cloud interconnect. So cloud interconnect let you connect your own premise or the data center you can think of with Google Cloud Platform. The additional advantage which you get it out of cloud interconnect is you have dedicated connection to GCP directly, and that's where you can exchange the data, you can exchange the network configurations. Like if you have a sub-network kind of implementation in your own data center, and your resources, virtual machine or physical servers wants to connect to the GCP resources, or GCP wants to connect to your own servers, that's where cloud interconnect will be able to help you to have dedicated internet connection or interconnections between your premises with Google Cloud Platform. So high level features, it's a low latency, highly available service that you can use it to connect your on-premise to Google Cloud Platform. You can have dedicated and partner connection options. So you may have a location wherein you can get connected to Google for its POP location, but there are some companies, they do not have interconnections or the location exactly near to the Google POP location. That's where you can go with the partner connection option. It supports RFC 1918. What does this mean? This means is you can have network exchanges between your on-premises and cloud, and all of these resources can talk to each other. You can create IP space, IP ranges, that the way which we have seen it in VPC, right? The similar way you can have the network connections or support between your on-premise or the office with your GCP VPC. And it is a direct pipe or private pipe you can think of. It is like data center from your data center to Google Cloud premises. Another option that we have is direct or partner pairing. And why do you use it? So this is not, you can think of, you want to exchange the network between on-premises with Google Cloud Platform. So everything is, you can think of everything is there in your in the Google, and you want to just take down your egress fees and you want to have high speed connection, and that's where you use direct peering. You're not exchanging any network information with Google Cloud Platform using peering option. So the features, you can have direct connections with Google or partner wherever, if you are not available there with the direct connection. You can have VPN, which you can configure, or direct internet, like public internet, and you want to reduce the cost of egress fees, right? And that's where you use direct peering. The third option that we have is cloud VPN, and this VPN is, you can think of traditional VPN. So why do you use it? It has got a SLA, an SLA of 99.9 service availability. You can have site-to-site connections, and you can create multiple connections to cloud environment or GCP environment from your own data center or offices. It supports Cloud Router, and we are going to get into details of what is that and what is that means to us as a Cloud Router. But you can think of, if you want to exchange the network information from your own premises with the GCP, because that's how GCP service resources can discover your resources on premises, the Cloud Router can be used. And you can have encryption or secure traffic using Cloud VPN, and that's where you use Cloud VPN. So in total, what we are going to look at is Cloud Interconnect, Cloud Direct and Carrier Peering, Cloud VPN, and Cloud Router. Cloud Router is just an additional, you can think of the service which you need to use it to announce the network changes if there are any. And we are going to get into details. This is high level, you can think of decision tree, and based on this decision tree, you want to use one particular service over the other service to connect your on-premise data or on-premise office or your data center to Google Cloud Platform. If you look at very high level, do you need direct access to your private computing resource on GCP? The answer is no. That's where you go to peering options, right? So this is where you are just accessing Google Cloud, right, from on-premises, and not your cloud resources accessing your on-premise data, and that is where it differs, right? Do you need to connect your G Suite? Yes. And can you meet peering requirement? If at all you are there in Google's location, you can do direct peering. If at all you are not there, there are partners out there who can actually get you connected to Google with their own connections, and that's where you use carrier peering. So this side, that's where you want to exchange the data between your on-premises and Google Cloud Platform with the interconnections or the networking steps, and that's where you take this route. Do you need to extend your data center to the cloud? Yes, that's the requirement. Do you encrypt the sensitive information at the application level? If you encrypt the sensitive information on the application level, you can just go ahead and get into interconnect, because interconnect does not provide you the encryption for that particular pipe. If at all you need an encryption because your application does not do it, you should go for Cloud VPN. Okay, so if your application is encrypting it, or you do not need any encryption for your data, you can take the interconnect route. Can you meet Google's at one of our POPs location? And that's where it says, if at all you are there in the POP location, that's where you can choose this route, or you just go ahead and talk to interconnect partner and get it connected to Google, right? Is your need 10 GB or more? And that is where you have direct connections, because if it is less than 10 GB, Google recommend it to go with the partner because it's less, it's cheaper, right? Not going in too much detail here, but the high level thought here is, if you need an SLA, that's where you will choose dedicated interconnect and VPN. If you are least bothered about SLA, you will choose direct peering or carrier peering. Also, more importantly, if you want to exchange the network from your own data center with Google, or you want to have direct connectivity between these two, your own data center and Google Cloud Platform, that's where you will choose dedicated interconnect or Cloud VPN. If you do not need, your on-premises resources talking to Google Cloud Platform, that's where you choose direct peering and carrier peering. If you are just accessing G Suite applications or collaboration platform and you want to reduce the egress fee, you are just going to go ahead and use direct peering or carrier peering based on where you are or where you are located. Okay, that's in a nutshell. We are going to get into detail of Cloud VPN in next lecture. Thank you. Where you can actually go and explore the hybrid connectivity options, you can go to the console and you can go inside the networking, and you have hybrid connectivity, and that's where you see three options, right? VPN and interconnects are the connection option, and Cloud Router is just exposing or announcing your internet changes or network changes. So if I go here, you will not be able to see peering option here, because peering is supported out of G Suite connection and not as a part of Google Cloud Platform connection. So you can go here and create a VPN connection. If you want to have VPN connection, you can go here and do interconnect connections. If at all you have data center, and you can replicate, and you can have cloud router connected, created out of this one. We are going to see in demo for VPN. I will not be able to show the demo for interconnect because I do not have the data center to connect to, but I can show you the demo from one region to another region on the Google Cloud Platform itself, and then we'll add cloud router as well to announce the network changes, and we are going to see that in the demo as well. So this is all about the hybrid connectivity, guys. If you have any questions on here, you can wait for the theory for individual services, or you can ask me in our questions. Thank you. So in this particular demo, we are going to see the bastion host, how you can actually go ahead and set up the bastion host. What I'm going to do is I'm going to use one of the virtual machine which is already there in the existing, which I have created in existing lab, and then I'm going to delete the external IP address for that particular server machine, and then I'm going to create another virtual machine in the same subnet, and I'm going to connect that. So this is just I just wanted to show you that how you can actually delete the external IP and then how you can access it from outside. So I have these virtual machine instances. Let me go ahead and delete the IP address, external IP address for this one, pvm1, and then go to edit. I had to delete the network tag which was allowing all the traffic. I have deleted the external IP address, and then I'm going to save it. This is saved now. You can see that for pvm1 there is no external IP address, so you can't actually connect this one from outside. Now, without actually creating any other machine right now, I can just treat pvm2 as a bastion host. I can just go here, and then I can just do SSH to the internal IP address. Right? Voila. It was so simple. So you can actually do SSH to the host name as well, right? pvm1. See, you are already in. So this is how you can set up the bastion host. I hope you understand this one. This is very quick demo. I just try to utilize whatever I had created in earlier demo for this one as well. This concludes actually the virtual networking configuration. If you have any question on this one, just let me know. Otherwise, you can move to the next section. In next section, I'm going to cover the interconnect. So if you have, say, infrastructure or your own data center and you want to connect to a Google Cloud Platform for additional services, how you can actually do the interconnect, that's what we are going to see it. In addition to that, VPN connection, DNS, Cloud DNS, and Cloud CDN. Thank you. Stackdriver. Using Stackdriver, you can do cloud monitoring, logging, trace, debug, and error reporting. We already saw the core services like computing, database, storage, and networking, right? But all of these services needs provisioning, monitoring, auto-scaling, load balancing, right? So all of that, we need to have some infrastructure services who are managing those resources in the cloud, right? And that's where resource monitoring comes in a play as a Stackdriver offering. Stackdriver monitoring does platform or system application matrices. You can do health check, uptime check. You can create multiple dashboards where you can monitor, and you can configure even alerts in Stackdriver monitoring. In Stackdriver logging, you can have platform, system, or application log. You can do log search, view, or filtration. You can do log-based matrices. You can do debug in a production using Stackdriver debug. You can take conditional snapshot, and it has got IDE integration as well. Using Stackdriver trace, you can do latency monitoring per URL latency sampling. And in error reporting, you can do error notification and error dashboards. So how Stackdriver is used? Stackdriver is actually a multi-platform cloud monitoring service. You can have GCP projects. You can monitor GCP projects in terms of monitoring, debugging, error reporting, logging, and trace. But you can also do that with AWS projects, right? So you can do AWS monitoring as well. So Stackdriver works with GCP as well as AWS. Stackdriver needs to have host project to have an account, and you can enable billing account around the host project. This host project is in Google Cloud Platform, so you cannot have. So if at all the services which are there in AWS, you cannot have its account used in GCP. You need to have a host project account to have this monitoring enabled. So when we say Stackdriver is very much integrated with all the services about out of GCP. Okay, so what are the benefits having actually the pre-integration, right? So you can do monitor multiple clouds, AWS and GCP, and those connectors are already available in Stackdriver. You can identify trends and prevent issues. You can reduce monitoring overhead. You can improve signal to noise ratio, and this means is you need to have a good responses over the bad resources. That's where you using Stackdriver you can actually improve that, and you can fix the problem very quickly if you understand it very early. Let's go ahead and get into Stackdriver monitoring.
Hello, welcome to the section on Big Data Service from Google Cloud Platform. Big Data Platform Service is USP or unique selling point for Google Cloud Platform and one of the oldest service from Google. Big Data Platform Solutions help customer to process huge amount of data without managing the underlying infrastructure. For enterprises or customers, it really matters how easily or efficiently they can ingest the data, if it is stream or batch or existing data, process the data or store the data, do data exploration using visualization, or report the data. Google Big Data Solution provides different solutions to satisfy all of these requirements or similar requirements. This is Dhanaji. I will take you through Google's Big Data Solution overview. Cloud certification does not cover in-depth aspect of big data solutions, but what is necessary as it's one of the critical service from GCP. So let's go ahead and get started. Big data solution as a PaaS, platform as a service. Google offer big data solution as a platform service, and different options on big data services are Google BigQuery, which is EDW or enterprise data warehouse in GCP, Google Data Flow, or you can say stream processing, Google Data Proc, which is Hadoop and Spark clusters, Google Cloud Data Lab, data exploration tool. Some of the other services which can be treated or they have a consolidated into big data service are Google Cloud PubSub and Google Genomics. Google BigQuery is fully managed enterprise data warehouse for large-scale data analysis. Google BigQuery. It's fully managed enterprise data warehouse for large-scale data analytics. It's petabyte scale and low-cost enterprise data warehouse for analytics. BigQuery is serverless. There is no infrastructure as such to manage, and you don't need a database administrator. So you focus on your analyzing the data to find meaningful insight using familiar SQL. Some of the product features of BigQuery are Flexible data ingestion. So you load your data from Google Cloud Storage or Google Data Store or stream into BigQuery at hundreds of thousands of row per second to enable real-time analytics into your data. It's globally available. So you have option to store your BigQuery data in European locations while counting benefits from fully managed service now with option of geographic data control without low level cluster maintenance or headache. Security and permissions. You have full control over who has access to the data stored in Google BigQuery. Shared dataset is not impact your cost or performance. Cost controls. BigQuery provides cost control mechanism that enable you to cap your daily cost or to the amount that you choose. Highly available. Transparent data replication in multiple geographic means your data is available and durable even in case of extreme failure modes. It's fully managed. In addition to the SQL query, you can easily read write data in BigQuery via Cloud Data Flow, Spark, and Hadoop. Connect with Google products. You can automatically export your data from Google Analytics Premium into BigQuery, visualize it using Data Studio, and analyze data stored in Google Cloud Storage. Automatic data transfer. The BigQuery data transfer service automatically transfer your data from partner SaaS applications to Google BigQuery on scheduled or managed basis. This is all for BigQuery. So in nutshell, what you need to understand is BigQuery is enterprise data warehouse. Google Cloud Data Flow or Apache Beam. It is a stream or batch data processing. So Google Cloud Data Flow offers a unified programming model and managed service for executing wide range of data processing patterns including stream analytics, ETL, and batch computing. Cloud Data Flow frees you from operational tasks like capacity planning or resource management and performance optimization and like that. Some of the product feature of Data Flow. It has got a automatic resource management. So Cloud Data Flow automates provisioning and managing processing resources to optimize or minimize latency, maximize utilization, no more spanning of instances by hand or reserving them. Dynamic work rebalancing. Automated and optimized work partitioning dynamically rebalances logging work. And no need to chase down hotkeys or pre-process your input data. It's a reliable, consistent, and exactly once processing provides built-in support for fault-tolerant execution that is consistent and correct regardless of data size, cluster size, or processing pattern or pipeline complexity. It's a horizontally auto-scaling of worker resources for optimum throughput result in better and overall price to performance ratio. It supports unified programming model. Apache Beam SDK offers equally rich MapReduce like operations, powerful data, windowing, and fine-grained control or correctness control for streaming and batch data alike. It's a community-driven innovation. So developer wishing to extend the cloud data flow programming model and can fork and or contribute to the Apache Beam. So you can actually think of this data processing logic. Google has open sourced it in the name of Apache Beam. In nutshell, what you can actually see is data processing can take a data from stream or a batch of any kind, and we'll talk about what is PubSub and all of that. But it can take a batch job or stream job. It can process into data processing logic, which is in data flow, and then it can pass the information to either the BigQuery, cloud machine learning, or Bigtable, from which you can draw your either machine learning analytics or you can see the insights from the data. Cloud Data Proc. It's a faster, easier, more cost effective way to run your Spark and Hadoop. So you can actually think of Dataproc is your Hadoop cluster or Spark cluster. So use Cloud Dataproc as a managed Spark or Hadoop service to easily process big data set using the powerful open tools in Apache Big Data ecosystem. A cloud data proc integrates with storage, compute, and monitoring services across the cloud platform products, giving you a powerful and complete data processing platform. Some of the features of Dataproc: it's automatic cluster management. So managing or deploying, logging, monitoring let you focus on your data and not on your cluster. So your cluster is stable, scalable, and speedy. You don't have to manage the cluster. A resizable cluster. So cluster can be created and scaled quickly with variety of virtual machine types, disk size, number of nodes, networking options. It is integrated with other GCP services, and you can actually plug this with cloud storage, BigQuery, Bigtable, Stackdriver logging, Stackdriver monitoring, which gives you a complete and robust data platform. Image versioning. Image versioning allow you to switch between different versions of Apache Spark or Apache Hadoop and other tools. It's highly available. You can run your cluster with multiple master nodes and set the job to restart on failure to ensure that your cluster and jobs are highly available. Developers tools. Multiple ways to manage your cluster, including an easy to use web UI, Google Cloud SDK, RESTful APIs, and SSH access. Initialization actions. You can actually run initialization actions to install or customize settings and the libraries which you need when your cluster is created. Automatic or manual configuration. Cloud Data Proc automatically configures hardware and software on your cluster for you for while also allowing you to manually control the configuration. You have flexible virtual machine which you can use. So cluster can use custom virtual machine type or printable virtual machines so that you have perfect size for your need. Cloud Data Lab. Cloud Data Lab is an interactive notebook based to explore, collaborate, analyze, visualize the data. It is integrated with BigQuery and Cloud Machine Learning to give you easy access to your key data processing service. So this is a supplementary service for your data analysis or exploration. Some of the product features, like other big data solutions, this is also integrated with other GCP services. The Cloud Data Lab simplifies the data processing with your Cloud BigQuery, Cloud Machine Learning, Cloud Storage, and Stackdriver monitoring. Authentication, cloud computation, and source controls are taken care out of the box. You don't have to worry about. It has got a multi-language support. Cloud Data Lab currently supports Python, SQL, and JavaScript for BigQuery as a user-defined functions. Notebook format. Cloud Data Lab combines the code, documentation, results, and visualizations together in an intuitive notebook format. It's a pay-per-use pricing, so only pay for the cloud resources when you use. Interactive data visualization. Use the Google charting for easy visualization. Machine learning. So supports TensorFlow based deep machine learning models, scale training, and predictive via specialized libraries for the cloud machine learning engine. IPython support. Data Lab is based on Jupyter, formerly IPython. So you can use a large number of existing packages for statistics, machine learning, etc. And it's open source. Cloud PubSub. Cloud PubSub is ingest event streams from anywhere at any scale, reliable real-time streams analytics. PubSub is serverless, large-scale, and reliable real-time message processing service that allows you to send and receive messages between independent applications. You can leverage the Cloud PubSub's flexibility to decouple the system and components hosted on cloud platform or elsewhere on the internet. By building on the same technology Google uses, Cloud PubSub is designed to provide at least once delivery at low latency with on-demand scaling to tens of millions of messages per second. So some of the product features: at least once delivery. It synchronizes cross-zone message replications per message receipt tracking ensures that at least once delivery at any scale. It's exactly once processing. With Cloud Data Proc supports reliable, expressive exactly once processing of Cloud Pub Sub streams. No provisioning. So Cloud Pub Sub does not have shards or partitions. Just set your quota, publish and consume. It integrates with other GCP services, open APIs, and the client libraries, even libraries in 7 languages, support cross cloud and cross hybrid deployments. Global by default. You can publish from anywhere in the world and consume from anywhere with consistent latency and no replication necessary. Compliance and security. Cloud PubSub is HIPAA compliant service offering fine-grained access control and end-to-end encryption. You can actually visualize in this particular picture as Cloud PubSub is an ingestion engine from any application devices or any data set, and that can actually pass the information or ingest the data into the cloud data flow. Likewise, there are many more use cases for Cloud PubSub. Probably I can create another video to detail out PubSub, because PubSub is much more important service, not even for big data, but other application in GCP domain. That's it for this particular lecture. So you can actually think of big data is a managed service. You don't have to provision the resources in majority of the cases, and you don't have to provision the resources. You just need to use it, and based on how much you use it, you will be charged. So it is pay as you go. Amount of data, whether it is amount of data, amount volume of data which is ingested, or data is processed by those applications. Cloud architect on the big data will ask about overview questions only. You need to have understanding on what is what to pass the exam. I will create a detailed course on big data with the demo for your understanding only, or if you are planning to give data engineer certification, it will be useful. That's it for big data as an overview section. If you have any questions, let me know. Otherwise, you can move to the next section. Thank you. Hello. Welcome to this section on artificial intelligence or machine learning service from Google Cloud Platform. Artificial intelligence platform service is another USP besides big data for Google Cloud Platform, and its oldest successful service where they don't have almost any competition. AI or machine learning platform solutions help customer to use AI or humanization of their own software data without managing underlying software or infrastructure. Enterprises or customers, it's really matter how easily or efficiently they can use machine learning, APIs, speech recognition, image analysis, video analysis, text analysis like sentiment analysis, or language translation, which we know translator.google.com. Machine learning, along with other services, provide solutions to satisfy all of these or similar requirements. This is Naji. I will take you through Google's machine learning solution overview. Google certification, cloud certification does not cover in-depth aspect of machine learning solutions, but what is necessary like big data, as it's one of the critical service from GCP. So if you are ready, let's go ahead and get started. AI or machine learning solutions is platform or software as a service. Google offers artificial intelligence or machine learning solutions as a platform service, and different services under AI or GCP are cloud machine learning, which is Tensor, cloud video intelligence API, vision API, cloud speech recognition API, cloud natural language API, cloud translation API, and cloud job discovery. So let's understand what is cloud machine learning. So it is fully managed machine learning on any data, any size. It's a TensorFlow implementation of machine learning. So Google Cloud Machine Learning Engine makes it easy for you to build sophisticated large-scale machine learning models that covers a broad set of scenarios, from building sophisticated regression models to image satisfaction to image classification. Some of the product features: it is integrated with other Google services and designed to work with data flow for feature processing, cloud storage for data storage, and cloud data lab for model creation. You can discover and share samples. So machine learning is tailored to sample your data for industry use. It's hypertune. It's built better performing models faster by automatically tuning your hyperparameters with hypertune instead of spending many hours to manually discover values that will work for your model. So it is managed service which focus for you to focus on model development and prediction without worrying about the infrastructure. So managed service automates all the resource provisioning and monitoring. Scalable. Build your model for any data and any size, any type. Managed distributed training infrastructure that supports CPU and GPU. Accelerate your model development by training across many number of nodes and running multiple experiments in parallel. Notebook and developer experience. You can create and analyze models using the familiar IPython notebook development experience with integration to Cloud Data Lab. Portable models. You can use open source TensorFlow SDK to train your models locally on the sample data and use Google Cloud Platform for training at a scale. The models are trained using Google Machine Learning Engine and can be downloaded for local execution or mobile integration. So this is all about the cloud machine learning. So you can actually think of this as TensorFlow implementation with additional SDK or APIs for you for ease of use. Cloud Video Intelligence API. You can search discover media content, which is video here. A Cloud Video Intelligence API makes videos searchable and discoverable by extracting metadata with easy to use REST API. You can now search every moment of every video file in your catalog and find every occurrence as well as its significance. It is quickly annotate videos stored in cloud storage, and it helps you identify key nouns entities of your video and when they occur within the video. Some of the product features: it will give you insight from your videos. So APIs allow you to extract actionable insight from the videos files without requiring any machine learning or any computer vision knowledge. Cloud Video Intelligence API improves over a time and new concepts are introduced and accuracy is improved. You can have label detection. So it detects entities within the video such as dog, flower, cat, and like that. Short change detection. It can detect the changes in scenes. Recognitions. It can specify a region where the processing will takes place. Integrated with other GCP platform. It can access via REST API or client libraries over 7 languages to request one or more annotations type per video, and we'll see how that actually happens in small demo. And you don't have to manage any infrastructure for this one. As an example here, I just took it from the website itself. You can actually go ahead and give the video to the API and it will give you video labels. It will give you short changes and short labels, and then it will give you REST response and you can use that response in your programs. As an example here, let me pull the demo video. So when you go to actually products and machine learning and video intelligence API, you can either select sample API, sample video there. Let me select any of this one, right? This is going to take time because ultimately it has to complete the analyzing the video. You can go ahead and try this on website on your own and you'll get the outcome like this one. Cloud Vision APIs. Google Cloud Vision API enables developers to understand the content of image by encapsulating powerful machine learning models in easy to use REST API. It quickly classifies your image into thousands of categories, which is already defined, and detects individual objects and faces within the images and finds, reads printed words contained within the image. You can actually build the metadata of your image, catalog, moderate offensive content, uh, or enable new marketing scenarios through images sentiment analysis. It analyzes images uploaded in the request or integrates with your image storage on the cloud storage. So some of the product features of image APIs, it's label detection. You can detect broad set of categories within the images ranging from models to transportation to animal. It can detect explicit content. It can detect logos. Landmark detection is also possible with Vision API. Optical character recognition. It can detect and extract text within the image with support for broad range of languages and along with support for automatic language identification. You can have face detection, so detect multiple faces within the image along with associated key facial attributes like emotion, state, or wearing headwear. Image attributes. It detects general attribute of image such as dominant color and appropriate crop hints. It can detect web detection. Search the internet for similar images. It is integrated with a REST API. That's the Vision API. Actually, I have passed one of the image from Seattle and then it has given me some of the information here. So label, it says it is city, skyline, metropolitan area, skyscape, metropolis, urban area, D-time. At the same time, it can actually give you the properties, image properties, and whether the content is adult, spool, or medical, or violence. If I go to the website for image, let me let me bring one of the image and let us try to understand more of this particular image. So it has given you the information like mixed use, urban design, neighborhood 81% chances, it's real estate 69% chances, condominium 68%, city 67%, shopping mall 63%, plaza, trees, recreation, right? If I have to go and click web, you can actually very well see that it's a Microsoft Visitor Center and there are chances, more chances. Microsoft Redmond campus, building 111 to be very precise, Microsoft Corporation. The text information which you have here is EL, I don't know where it is resides. The color properties you have it based on these particular chops. Safe search, adult it's very unlikely, medical very unlikely, in violence very unlikely, and this is the outcome. In your JSON you can actually very well see that it's urban design, neighborhood, and likewise you have multiple information, whether it is safe search very unlikely, and like that. So you will get that actually from the API as an outcome. And that's the Vision API. Google Speech API. So speech to text conversion. So Google Cloud Speech API enable you to convert your audio file into text by applying uh, neural network models in easy to use APIs. The API recognize over 100 plus languages and variants to support global user base. You can translate the text of the users detecting to an application microphone or enable command line or uh, command and control through the voice among many other use cases. Google Speech API. So it is speech to text conversion. Google Cloud Speech API enable you to convert audio into the text by applying neural network model in an easy use APIs. The API recognizes over 100 plus languages and variants to support global user base. You can transcribe the text of users detecting to an application microphone or enable command line control through voice among many other use cases. Some of the product features. It is powered by machine learning. The return results are in real time. It is context aware. So speech recognition can be even tailored for your context by providing separate set of words hints to each API call, which is useful especially for device and app control use. It works with app across any device. So this API supports any device that can send REST call or gRPC request, including phone, PCs, tablet, IoT devices, and whatnot. Automatic speech recognition. So automatic speech recognition ASR powered by deep learning neural networking power your applications like voice search or speech transcription. It has got a global vocabulary. It recognizes 110 languages and its variants with extensive vocabulary. Streaming recognition. It returns recognition results while the user is still picking. The word hints speech recognition can be customized to a specific context by providing set of words and phrases that are likely to be spoken, especially useful for adding custom words and names to the vocabulary and in voice control to use case. It's a real-time and pre-recorded audio support as well. Noise robustness. It can handle noise audio from any environment without requiring additional noise cancellation. Inappropriate content filtering. It filters inappropriate content in text results for some languages. Integrated API. Audio file can be uploaded in the request or integrated within Google Cloud Storage. Some of the example here which I tried to do it earlier, you can convert your, so I was speaking it and then it was converting in real time. I selected another language here and then that has also converted into it. Let me go ahead and show you how actually does it work. Hello, it's me. We are learning Google Cloud Platform. One of the other language, let me select, which I know. गूगल बहुत अच्छा काम कर रहा है. अच्छा चल रहा है. And this is how it works in real time. So that was speech API. Cloud natural language API. You can actually derive insights from your unstructured text. So Google Cloud Natural Language API reveals the structure and meaning of text by offering powerful machine learning model in easy to use REST API. You can use it to extract information about the people, places, events, and much more mentioned in the text document, news articles, or blogs. Some of the features. You can have a content classification relationship graph. So you can classify your document by common entities around 700 plus general categories such as news, technology, entertainment. You can build relationship graph of entities extracted from the news, Wikipedia article, or by using signal from the state of art syntax analysis. Syntax analysis. You can extract tokens and sentences to identify parts of speech, POS, and create dependency freeze each sentence. Entity recognition. Identify entities and label by types such as person, organization, location, events, products, or media. You can have sentiment analysis. You can understand overall sentiments expression in the block of text. The content classification. You can classify document predefined 700 plus categories. Sentiment analysis. You can understand overall sentiment expression in the block of text. Content classification. You can classify your document in predefined 700 plus categories. Multi-language enables you to easily analyze text in multiple languages including English, Spanish, Japanese, Chinese, French, German, Italian, Korean, and Portuguese. Integrated REST API access via REST. It can be uploaded in a request and or integrated with, you can say, you can store that in cloud storage. So one of the example here which I have put forward is, and the output which I got it is, you can see the first one, the Google is an organization, that's what it has detected. The sentiment, the second one is the users, third one is the phone, Android, the person name, Mountain View is the location, consumer electronics and event, consumer goods which is phones, and keynote. Let us analyze the content here. Let me pull. In here. So it has detected location, Native Americans, war, history, war, an event again, North America, George Washington, people, colonies, shelters, leaders, location, colonies, other colonies. Yeah. So these are the information which you will get it after analyzing this particular text which I copied it from this one. And that's how natural language APIs will help you to understand more about your the text. Google Cloud Translation API. It is fast dynamic language translation. The Google Cloud Translation API provides simple programmatic interface for translating an arbitrary string into any supported language. Our translation API is highly responsive, so websites and applications can integrate with the translation API for fast dynamic translation of your source text from the source language to the target language. Some of the product features of translation APIs. You can translate many language. So somewhere around 100 plus language is supported currently. You can detect the language. It has got a programmatic access. So with APIs, you can RESTful APIs, you can use that in your programs. You can do text translation. It's a continuous updates. So behind the scene, the translation API is learning from the logs, analysis, human translation examples, existing language pair to improve, and new language pair comes in online with no additional cost. Translation API has got an adjustable quota. You can increase from 2 million per character to 50 million per character, and even that can be changed. It is affordable and easy pricing. Some of the example here, I don't have to actually give you a complete example here because many people are used translator.google.com. It's a similar context, it is just REST interface to that. That's it for AI or machine learning. Cloud architect exam particularly ask only the overview part of this particular section, and that's it. If you have any questions on machine learning or AI, please let me know, otherwise you can move to the next section.